As we're live, there we go. Then let's go double ping. Where'd my fingers go? That is not how you spell architecting. I don't like that. Architectonic. Architecturing. Architect, because the CH is there. So architecting is just not a word that it recognizes? Is architect not a verb? Cool. Well, you can join this Discord where I don't know how to spell words in the description. And I don't think, I really wish OBS gave me the chat. No, it does sometimes. Is this OBS Studio? It is. Can I not enable a chat window in OBS, or do I just have to stay in YouTube Studio? Hello. Hello, hello indeed. Let me put this back in my primary window so I don't have to switch between it all the time. Okay. I guess before I forget, we want slightly bigger screen. That's probably too big. Let me know if the text needs to be any bigger, or if there's encoding problems or something. Let me know how the mic sounds. I'm on a new setup and I didn't like save off any settings, so I just kind of guessed. Hopefully the mic sounds good. I'm not running much, so the fan shouldn't spin up all that often. Mic sounds good. That's good. I didn't actually think about where to start. I started architecting, whatever. Scaffolding out a project here. I don't want it to be too terribly complicated, but I don't want to require people to learn knob. So I've also set up a makefile. The makefile will probably be the primary documented way of building this, for example. I might set up a CMake file as well. I'll probably support a few different ones since we're going for educational. I don't want to be all esoteric. People should probably learn how their build system works, and knob is very simple, but it's also not something you can easily Google. People can Google makefiles and go learn about makefiles, so we're going to support makefiles. We're just going to run with make plus the name here. I've decided to call this language Hibiku. I've already set up a header file where I can throw in a version and some information about that. We've got the MIT license. I don't think this is on GitHub yet, so we could go ahead and GitHub. And let's create a new repository so we can go ahead and start syncing some code up here. New repository, Hibiku. Hibiku is available. An educational programming language. I have a handful of ideas for how to make this actually educational, but we'll figure that out in a second. Okay, so in here, don't think I've made it. I have. Okay, so it is already a Git repository. Claim format, get ignored, license, make file, readme, compile file. Okay, all of this looks fine. Nothing in here is here that I don't want. So git add and commit, initial commit. Right, we'll just do that. I only want to add a remote. This one, origin, and it's called origin. This one, I'll leave it as origin for now. I might change. Main. Cool. So now the repository exists. I believe the description already lists the repository, so it should be the correct link. It is. Cool. So you can now view the source code to whatever we work on today whenever you want. It's in the description. So what I want to do with Hibiku here this new programming language. I make so many programming languages. Don't worry. Laie, my other programming language, is not dead. I'm still working on it. It just has not been fun to stream because it's really complicated and I kind of need just the time and space to work on features. So you'll see me talk about it all the time if you haven't already. In my Discord server here, we talk about all kinds of things. Lots of programming languages, though. Hello, Omar. But instead of working on Laie on stream, like I said, I don't really want to at the moment. I do kind of want to get back into streaming with something a bit more educational, a bit more back and forth. I can talk to chat, answer questions and comments, whatever. Try to actually teach people something instead of just doing what I'm doing and not telling people what's going on. So I wanted to create a much simpler programming language with a couple of different goals. In Laie, we even talked about OS and brainfuck. Yeah, we did. Omar, I'm thinking compiled and interpreted to some extent, so I can teach both. There's a lot of really recent what's the word I'm thinking of? A lot of recent articles or books about interpreters, and I don't want to completely omit interpreters. They're going to be very good, useful teaching tools for visualizing data and how code is executed. But I think I want to design this in a way that it can also be compiled, because I do eventually want to get into generating different kinds of code, be that a transpiler to C or to an LLVMIR, or maybe eventually for my own learning, different machine backends, like generating assembly as text or object files for whatever target machine we want. So I'm going to keep the language as simple as I can, but I also want it to have some fancy, fun features, like closures, for example. Compiling closures down manually is going to probably suck, but they're very easy to interpret. So we'll see if I get around to keeping closures for both, or just not doing them at all. Regardless, closures are probably going to be one of the last features we add to the language because, like I said, I don't really want to use them. This is kind of the syntax I'm thinking. Basically just Lua plus type annotations. Because a lot of compiler or a lot of interpreter stuff also kind of omits type checking. And they just use those dynamic, everything's one type and you check it at runtime systems, which is not terrible, but I want to teach more about compilers than just typeless interpreters, right? So if we're going for a compiled language, we're going to want these kinds of types to teach type checking. I'm also wondering what I'm going to do with AST generation and SEMA, because normally when I build languages that are this easy to parse, I don't even build an AST, but an AST is a good teaching tool. So I could just go straight from parser, straight from tokens through the parser, output our IR. Hello. That's two new people. That's, God, the text is so small on this monitor. We've got, I don't know how to pronounce Ouija board. We've got Ouija board and Coronar. You're a coroner and you're a Ouija board. Cool. Hi guys. Yeah, so a lot of people omit the semantic analyzer and type checking from it's especially interpreter books. I haven't read a lot of compiler books myself. I heard that old compiler books are not great, like Dragon Book is mediocre, but it was standard, so everybody knows it. So I don't want to omit it myself. I am planning to write about this if I get to a point where I'm happy with where the implementation is going. So I've got in another repository over here, let's just make a new tab. On my website, I've created a quick template that I can start filling out. So if I'm going to do it, I'm probably going to call it 0 to compiler. And yeah, so here's hey, does this look good on the page? and I'd call it Hibiku, and here's some steps that I wanted to go through. And I'm probably going to write it as like a series of blog posts, maybe turn it into a book like Crafting Interpreters did, I don't know. But I can Python 3 HTTP server public HTML, and then go to 00008000 /0 to compiler chapter 0. Oh, because it's chapter 1, that's why. I really should like have it bookmarked or something. There we go, that's what we want. Right, so I've just got a simple template I can build out from that markdown file. So if I wanted to start writing without thinking too hard about it, I can do it and actually publish it to something that doesn't look like shit and put it online somewhere. That would be great. So that's the goal if I decide that I want to do that. How do I don't know. I have Chrome. Probably start doing dev in Chrome over here. Yeah, so I go 0000. Much better. Okay. I've also got Chrome here. Then I don't have to mess with my Firefox tabs, and that's probably a good idea. Anyway, so that's the idea. So I'm thinking we go with, I don't need this open anymore. I'm thinking we go with something similar to Lua with type hints, so we can do semantic analysis on types, type checking, but still have a simple, easy to parse language for for making it simple and easy to parse. We can get to an interpreter pretty quick. We could probably compile it pretty quick if we're not doing closures. So like this example, probably not a good example if we're going to go straight to compiling. We should probably hold off on closures for a while. But they're very easy to interpret. So yeah, so I left off with the question of, do I want to build an AST or do I want to go straight to the IR? Because if we're talking about something like Lua or similar languages, I know Lua goes straight from tokens to IR. It builds the bytecode in line and does its own backpatching and whatnot in line. So that would make it really, really quick to get to interpreting. And if we're just compiling and doing nothing else, that also makes it really quick to just go from bytecode to compiled code, right? We can make that transformation pretty quick. But abstract syntax trees, ASTs, are usually very important to most bigger compilers. So again, I don't necessarily want to skip on building an AST. And so as much as I don't want to for my own purposes, and I want to go straight to IR, it's probably better for educational purposes if we build an AST and then have a translation step to go from AST to IR. And I can probably make a note of that in the blog posts or book or whatever, that it's totally possible to skip the AST if you've got a simpler language like this. So I'll probably make lots of side notes. So like, you could do this or you could do that, or like, I don't know. So that's the kind of thing that's going through my head. What exactly do we want to do with this language? If you guys have any feedback at all on what you would want to see, I can try to align it to what people actually want to know about building a compiler. I want to assume that you know nothing about building a compiler, if possible. It's going to be hard to do because I know lots of things about building a compiler. So I need to hear from everybody else. Can you print all expressions and statements for debugging without constructing an AST? Can you print all expressions and statements for debugging without constructing an AST? Technically, but you're right. For debugging purposes, it's probably easier if the AST is there. Yeah, so I mean, we're probably going to build the AST. We have too many reasons to build the AST versus not to build the AST. So I think that's what's going to happen. You guys are going to see me build another Lexer live on stream. That'll be like the third time we've built a Lexer on stream. So I'll try to make that quick and easy. The Lexer shouldn't be all that complicated for this language. We're not going to do anything fancy with strings or numbers. So it should be a relatively short Lexer. The parser should also be a lot easier than what I was doing for Laie. You guys saw a little bit of that on stream before I went off stream and finished the rest of it. But it should be a very simple lexer and parser. We'll keep the AST as small as we can. So within a couple of stream episodes, we should be on our way to I guess, SEMA. We're not going to go straight from a parsed AST to IR, but there's not a whole lot to do in SEMA. I'm not going to make this terribly complicated in terms of SEMA. We're going to have order be important. We're not going to do unordered declarations because that requires you to do a whole lot more out of order. You have to rely on dependencies and stuff. So we're just going to go top to bottom. If you can't resolve something with the things that exist before it, like if you can't find create header because it exists at the bottom somewhere, it's just a semantic error. We're going to do things as simple as possible. Right? So. The other problem that I'm thinking is how am I going to teach this in C? Because I want to make this embeddable as an interpreted language, something similar to Lua, to teach that you can interpret things and embed things into other applications and why that might be useful. So I want to make it easy to embed like Lua would be. So I want to write it in C because embedding things from C, super straightforward. So I also have to balance teaching C versus teaching what I'm teaching. So a lot of things are going to be out of scope of this series probably. I'll probably answer them on stream and talk about it. But if I go into writing, we're probably going to gloss over like how do you do strings in C? Or how do you handle memory in C, right? That stuff's gonna almost certainly not get shown on stream. And speaking of, actually, I'm probably just going to grab some of my... Here. I've already got some helper libraries that I've been using for myself. They're very simple, but I'm probably going to grab them for this project. These 5 files right here. Are you going to generate a custom IR like you do with Laie? If so, it'd be cool to understand how you go about writing your own builders, etc. Yes, we're going to be doing a register-based, not SSA, IR, I think. It could do stack-based. Stack-based is technically easier, but I want to do register-based for this one, I think, because I didn't really have a good reason. Stack machines are a lot easier to do, probably easier to teach, but a register machine does kind of get us halfway to a register allocator. So if we go to the point where we're generating like machine instructions, I don't know, maybe it's easier to do a register allocator. I haven't thought that far ahead about it. If you guys would prefer to see a stack machine and how I build IR for that instead, then we can do that. Builders are not terribly difficult. Register machines can be a lot faster, yeah. Not having to manipulate. Like if you know the stack space in advance for your stack machine, then it's very similar to a stack or to a register machine if you do it right. Yeah, all of these are going to be saved. I don't understand that last question about the Laie syntax. All of these should be saved. I'm going to put them in a playlist. The Laie quote-unquote series that I didn't do very frequently is saved as well in a playlist. So I'll make sure that I include the link to that playlist in all future stream descriptions. And if I do anything off stream, I'll try to record it and do an off-stream upload. But I'm telling everybody when I stream in my Discord, if you come over here, you'll get a ping if you're on the stream notifications role. Just ask for it if you don't have it. You can join the Discord through the link in the description. Let me know if that doesn't work. But yeah, you'll see that in here. I guess I should have linked to it, you know, that's probably a good idea. Copy URL. I need to change this thumbnail. I need to make a new thumbnail image. I made this when I was on Windows, and I don't actually know how to make similar stuff on Linux. I'm on Fedora right now. I'm not familiar with how to use GIMP, so if anybody wants to teach me how to use GIMP or some other image editing program to make a new thumbnail, by all means. If somebody wants to give me a thumbnail, I will not say no. So yeah, we can probably talk about stack-based virtual machines, but I think we're going to implement a register machine because I like register machines better. Yeah, so these are the handful of libraries that I put together for myself to work in C a bit better. They're not that complicated, couple hundred lines each at most. Like my memory thing is 200 lines. My platform layer really is only there so I can remove colors from output to not affect terminal, like comparing standard output to a string doesn't work if there's color codes in it, right? So I can disable color codes. That's the only thing on my platform layer right now. My string library is only 250 lines of code just to get myself a string with an allocator. My dynamic array is actually really small. It's only 100-ish. Yeah, 100 lines of code to get a dynamic array. And that's because a lot of this is formatted by Clang. Normally, I don't format this nearly as verbosely, but yep, so dynamic arrays, and then a couple of defines for ANSI color codes for the terminal. Beyond that, we're going to be doing everything from scratch. I'm really bad at this kind of advice, other than just do it, see what happens. The question was, hello, any advice for someone who is new to C but wants to make really complicated projects like this? You just kind of got to get better. You got to do things in C. You got to learn from your mistakes. Hopefully, I will be able to teach you in this series how to do these kinds of things in C. So feel free to ask more specific questions as we get to them. But with such a general question, I don't know what to tell you other than just do it, and do it a lot. I've been programming for half my lifetime, so I'm only where I am because I did it. Then that's it. I did it. You could start with, how do you build a C file? If you don't know how to do that, you probably need to do that. For this project, we're using primarily a makefile, and a really simple makefile at that. I could make this even simpler if I removed this lib thing and just inlined all of our library files, which are 0 right now. We don't have any library files. But yeah, we're primarily using make here. You'll see a couple of other build systems. It'll let me comfortable building poorly written CLI tools. Hey, if you can build a CLI tool at all, that's like half the problem solved. The rest is just learning how to write good code and learning how C lets you do that. So we'll get into a lot of how I do that in C in this series. If you're not in the Discord, you should probably go join the Discord because you're going to see me talk a lot about my programming in C in this channel, in other channels here. I give you lots and lots to read through. You can ask as many questions as you want. Eternal here, incredibly smart and knowledgeable. I don't think I've already forgotten name. Stupid streamer mode. I can't remember your name. Gurpreet has been talking a lot about his compiler, but he doesn't really join any discussion. Maybe you can ping him too. He's pretty smart. Okie doke. Anyway, so we do a lot of talking in here. There's some very smart people. You can ask questions when I'm offline. Plenty of people will have things to talk to you about. But yeah, I'll get into how I like to design C applications, which has a lot of overlap with other languages in just different fashions. Sounds good. Yeah, I'll try to be as educational as I can with this series. That is the point. So I'm probably not going to fill out the README just yet, other than like, Hibiku is a programming language designed to help educate people on how to write interpreters and compilers. I realize that writing it in C is not necessarily as approachable as could be, but I want to show how to embed an interpreter as well as run it as a standalone application. C makes embedding just about anything and embed reference in a C library. Written to allow Right? So I mean, like, I don't know exactly what to put in here yet. I'm really bad at writing this shit. I need to get better at it, because if I'm trying to write blog post articles or a book, then yeah. So we're going to be learning how to write fucking English in an understandable and meaningful way while we're doing this as well. Maybe I write some of those blog posts on stream and you guys help me proofread. I don't know. We're going to figure it out as we go. But Hibiku. Let's go ahead and throw in how to build. We're just going to say make in the build should be as simple as running make in this directory. Making things understandable, yeah. After a few attempts, I can usually make something understandable, but that doesn't necessarily mean that it's clear or concise, right? So I need to work on like editing my thoughts down to something that is clear, understandable, and concise, and not just one of the three. The Hibiku, the Hibiku executable will be generated at the root in the same directory. Make. Cool. Then I could say usage, and for now we don't really know how you're going to use it, so I'm just going to say fucking Hibiku help. I don't actually know how this is going to be used yet, but you can always check this if there's up-to-date help information by passing the help as that fills out. So should is read. Cool. Anyway, so all I've done to scaffold this is the build system, a couple of folders, an example file that does way more than we're planning to do anytime soon because it's doing closures, but you know. Cool. So all I'm doing in the header file so far is defining some version information and two string helpers because I wanted to stringify the version information. I've made the version major, minor, and build separate integers. I made the combined version be the sum of those in this format, which should be, I'm going to use A for major, M for, or M for major, little m for minor. And then build should look like this, right? So the first three for build, the next two for minor, and then everything above that is major. That way you can actually compare versions against each other. So if I wanted to compare this version to version 1.1.1, that would be what you do. But what I should probably do is define HBK version, like value, integer, combined. Because if I just did HBK version as a macro here, that would give us major, minor, build, whatever, right? Let's call this like version number. And then we can have HBK version here, which can be major, minor, build. And this is major, this is minor, and this is build. And on that note, let's wrap all of these. And then version number is going to be version of HBK. I'm going to have to get really used to typing my prefix. Version major, HBK minor, and HBK build. And then I'm going to have to also get used to generating, or not generating, but writing inline comments. If we're trying to make this educational, then this needs to make sense to read as source code for beginners as well. The major version of the Hibiku library. That doesn't sound as clear as it should be. I know what that means, but the major version of, I'm just going to call it Hibiku, be a little bit more vague so I can explain it later. The minor version, and the build version. So if I go into, where's my Chrome? Chromium, Semver. We could steal a little bit of wording from Semver if we're using simplified semantic version, basically. So they call it patch, so I'm probably also going to call it patch instead of build. This replace match case build. Yeah, let's just do it through here. Match case build with patch, and it should match. So this is match case, but I actually want to replace preserve case. That's what I'm looking for. Boom. Okay. Cool tools. So let's link to Semver and say Hibiku follows a simplified version of semantic versioning. This library provides the major, minor, and patch version numbers. This library provides major, minor, and patch version numbers. That's macros. Also provided are string macros to convert a version to a single integer purposes of comparison. As well as a version string. That still doesn't sound super readable to, hello Zedrich, how you doing? We're discussing some things. I'm kind of flim-flonging about describing what the fuck a version is. So I'm actually just not even going to list major, minor, patch here because Semver should cover what that means. Combine the major, minor, and patch version numbers, patch version numbers into a single integer, useful when trying to compare two versions ordinally. Ordinally is probably not a word people will know, but I can't explain what ordinally means in line. I don't know. Okay. So then we could say the current version of Hibiku as an ordinal value. It at least gives somebody to look up, something to look up, or search or grep or whatever. The current version of Hibiku as a string. In the form major, minor. I'll probably use backticks for that. Major, minor, patch. Cool. Fancy C macro trickery to get strings. If you don't know what it means, don't worry too much about it. Okay, so where do we want to start with this? Probably from the beginning and just getting another Lexer scaffolded. We could also just start working on some other data structures, and because I know somebody asked about getting a builder set up. We're probably going to not do that for the Lexer, of course. We're probably not going to do that for the parser, right? I mean, we'll have some sort of a quote unquote builder for creating nodes, but I don't think we're going to have a full AST builder. We're definitely going to have a builder for IR. That's, again, going to be a register IR. And a lot of this is going to be internal. We're not going to expose a lot of this to the end user. So one thing I'm going to have to do is, see, knob is not doing this correctly. I'm going to come over here and say, if this, then I need to create an ends with, which I have already. Let's just go grab, Laye should have it actually. Let me reopen Laye, because if I go into knob, ends with, we don't have an ends with. And if we do, it's not immediately here. Bill, Bobby, Bob, cool. We don't have an ends with in Laye, but we should have it in Nashiora.com's knob. This one should have a string ends with. C string ends with. Okay. I'm just going to add that to our other knob here. Funk. Add to my knob. If not C string ends with file dot C continue, we're only going to add C files to knobs build because we are going to do some internal stuff. Like corn on the cob. Yeah, check in with me and do your job. Don't look up that song if you don't know what it is. I was in like 6th grade when I memorized the lyrics to that song. At this point, I only know like the first half, but yeah, funny song. So let's do a couple of things here. We want to start with, it's catchy. It's not the most, let's call it musically interesting. It's definitely not the most musically interesting song. Lyrically, it's they rhyme a lot of things. They get really, really good at one. What's the thing I'm looking for? The way they carry the rhythm, the meter, they get really good at that. The whole song sounds the same, and it's down to a science. Very interesting song. Lots of things to like about it. A lot of things not to like about it. If you don't like it. So we're going to do HBK is going to be the prefix for everything we do internally and externally. Hibiku is going to be our one includable, embeddable thing. If you want to embed it, you include HBK, or you include Hibiku.h. So we're also going to be going over some API design considerations for our public API. We're going to keep as much as possible internal to the application, not exposed to the end user. And our Hibiku file here is purely our public API, how people are going to interact with it as an interpreter, as a compiler, whatever, right? So best case scenario, even our Hibiku application here, hibiku.c, will not be reading any of these HBK files in the lib directory. It should still be able to only include hibiku.h and get interpreter functionality and compiler functionality all in one, as simple as possible. Part 1 or part 2? I didn't know there was a part 2. I know slob on my knob, and that's it. If there's a part 2, then I have no idea. So let's do. Hibiku will definitely want like a syntax.h for handling tokens and parsers, probably. We'll definitely want an ir.h for handling the internals of the IR representation. We'll probably want an interpreter.h. We'll probably want a like backend specification. So if we're starting at the front, we want like, I don't know, let's call it for now syntax.h. Hibiku syntax. But we could also, I guess, just call it Hibiku parse, HBK parser, because it's just because we have syntax. The parser itself is going to be incredibly simple. It's just going to be like a call to a single function, so it doesn't need its own header file. So we could just call this front end or parser. I do kind of want to steal some naming conventions from US source code. They do like not what I'm doing. Like anyway. 5.4, wow. Yeah, they do like LAPI, Lcode, Ltype. So what's in Lua.h? It has Lua conf included. Yeah, version major, minor, and release. You know, this is, looking at Lua's, this is entirely too complicated. We'll call these major. These will all be strings. We don't need the ability to construct anything from a major, minor, or patch. We already have a version string, a release number, times 100 plus 6. Interesting. But our Lua version, so let's just say HBK version here, is going to be, we'll even steal from Lua a tiny bit more and prefix it with Hibiku, and then it's going to be version major, version minor, question everything, make everything simpler. They don't even include the patch version, which is good. Then they just say define HBK version number, let's call it, and then we can make this, it'd be fucking 1 for right now, and 0 makes it an octal, so it's just 1. Really, I want this to eventually be like 101 or version 1.1 with no patch, like that. And we could go ahead and call it version 1. I have no qualms with that. So if we make it 1.0, let's just start working on Hibiku version 1.0. And then that makes it even easier to compare. We're not including the patch. And then, yeah, they do something very similar to what I do as well. They have a release number, which includes the patch. So I don't really need to do that for right now. Should we do that? Let me go, I'll put back up my chat. Should we include, that's the Hibiku is the name of the programming language that we're making for educational purposes. It is a, you can call it a scripting language. It's going to be a general purpose programming language that's going to look and feel a lot like Lua, but have more static analysis built in and be natively compilable. Like you don't have to download LuaJIT, for example. I want it to be embeddable, but I want it to be compilable because we're going to teach people how to build both with the same language, not have to read 2 different books kind of deal. So HBK version, let's, for shits and giggles, throw in a release number. That would be version number. And here's where I kind of want to go back to where we were without the strings, because then I'd have to manually upkeep which numbers are which. So if we're on 100, this is major times 100 plus minor. Major times 100 plus minor. Easy as. Then release number is version number times 100 again, plus patch. And since these are macros, we want to wrap them all in parens to make sure nothing goes wrong. Okay, so then HBK version would be this. And then version release would be the same thing dot the patch. So we just put this here, say version dot patch. So we can say I want to say, for the purposes of explaining these version numbers, X refers to the major version, refers as 1 on. Y refers to the minor version, and Z refers to the patch version. the version number is the major and minor version numbers. XYY. Major version is in the hundreds place, and the minor version is in the tens. I don't know if that makes sense. The release version number includes the patch version by applying the base version by 100. So I can, instead of saying the ones and tens, I can just say the lower two digits. This means the version, the minor version, takes the lower two digits, and the major fills out the rest. So that the release or the patch version number can take the lowest digits. This version number takes the form XYYZZ. The Hibiku version as a string, including the name Hibiku at the start. This string is in the form of Hibiku x.y. Then this is the Hibiku release version string XYZ. This includes the patch version, so the string is in the form XYZ, like that. Right, cool. That's a decent explanation of what these version strings mean, which is good, which is good. So now we get to start designing our internal and external API. Oh, I was looking at something. Because they have this. Interesting. Yeah, they have so many things. So let's do a few things. Do you guys have any preference on how granular these header files get? I don't want to make them so granular that they're kind of like useless to look at, but do we want to put like in Hibiku parser, does that want to include tokens, the AST, shit like that, the parsing functions? Or do we just want to have like HBK Lex be the thing that gives you tokens? Right, so we could say HBK Lex, this is responsible for tokens and lexing, and then HBK parse .h is responsible for reading in tokens and returning the AST. So then we have like HBK IR opcodes, ir.h for that. The interpreter, I don't even know what to call the interpreter. We could start factoring these into Hibiku exclusive string platform, whatever the heck, and not be using what I'm like. I could, okay, that's a better question for everybody here. I've already got a handful of libraries that I'm using for dynamic arrays, memory management, and strings. Would you rather me build that from scratch into Hibiku itself so that there are absolutely zero dependencies on external code? If yes, we can start there and build out a string library and probably an arena allocator. No idea. Cool. Then I think just for educational purposes, I am going to, yeah, let's delete all of my pre-generated stuff. So we are going to say hbk string.h for internal string purposes. The API is almost certainly going to deal with C strings unless it's like in the interpreter for like Hibiku internal interpreted strings, objects, and stuff. Those will be our fancy strings probably. So we'll do that there. HBK DS. If you include them in a repo, you don't have to rewrite them again. Yes, they were going to be included in the include folder. They're only a handful of lines of code each, so I don't really care either way, but if people want to see me write them and include them as part of the library versus a dependency in the include folder, right? HBK DS for like data structure, we're eventually going to want a hash map, probably. But we could have like a dynamic array and then include a hash map as well. So HBK vector is like a bad term if you wanted to include this in. I guess it's not a terrible term. If we're prefixing with HBK, then it's fine. So we could call it a vector, a list. Names are just hard. So we'll call it HBK list. Call it HBK vector. .h. If I do that, that looks fine, right? Yeah, HBK vector. HBK hashmap.h. Not Haskell. No. No, I'm not smart enough to write Haskell. Thank you very much. HBK alloc or memory. HBK memory.h. The problem with my original libraries that have, not this one, with Laye and stuff, they are single file header libraries, which are a little confusing if you're not, if you don't know how C works. So maybe this is better and we just include C files and not make them single header, right? So hibiku.h doesn't need to include any of these explicitly. We might want a configuration file later. That might be useful. So we have a lexer, a parser, memory management, IR. The IR won't be the interpreter though. So let's see, like VM, we could just call it HBK VM. HBKVM.h for interpreting it. And then we'll want some backends eventually, but I don't know what to call those. Compile, back. When we get there, we'll get there. I'm going to leave it at these for now. So let's start with what do we want in a lexer? And that might take us to the string and vector. We won't need a hash map for a while. That might take us to string and vector. So let's if and ref HBK lex h define if you don't know what a header guard is, that's what this is. Ask me if you don't know what header guards are. We'll have to go over them in the book, but I'm kind of gloss over them here because they're standard. HBK lex. So in lex, we want probably to just get a list of tokens, an array of tokens. So that would mean we need our HBK vector. So we could go implement a vector pretty quickly. Let's start with a very simple vector API without implementing too much just yet. So I don't have to talk about it until I'm ready. Vector.h. So what we're going to do is define HBK vector of t as t pointer. A vector list dynamic array in Hibiku is represented simply as a pointer to the underlying type. This gives us generic type, whatever the heck, the ability to access the type info of the underlying type implicitly rather than requiring the user specify it for every function call. Let's see, does not support generic types or introspection. Since all of the API for vector type is implemented through C macros, we can use things like size of vector to query the size of the underlying. That roughly explains why we're doing it this way. So then we need to type def something. For right now, we'll come back to that in a second. We're not implementing it just yet. Let's create a function to return a list of tokens as well as the token struct. So type def struct HBK, I almost typed LISE, HBK token. A token is rather simple. We're going to type def it as this. It is going to need a token kind, HBK token kind. So we're going to go build out an enum, type def enum kind, yes, HBK token unknown. That'll be our 0 value. A token is going to store all of the information related to a small subset of the source. If anybody doesn't know what a token means, I can explain it briefly. I'm definitely going to explain what it means when I write about this. High level, every word or symbol in the source text that we want to care about as a whole versus, separately is a token. So the word function here is one token representing the function keyword of the language. Create adder is one token representing an identifier, a variable name in the language, right? If you need more information than that, feel free to ask. I am happy to explain. Okay, so then we want to include HBK vector, because HBK vector is going to give us HBK vector of HBK token, HBK get tokens, read tokens, read tokens. We're going to need to read them from somewhere. We don't know where yet. To do where from? Reads all of the tokens from the source text into a vector. For simplicity in implementing other parts of this compiler, we don't support reading individual tokens. I guess that would be kind of simple, but it's slightly complicates look ahead in the parser, and I don't think we have anything that really cares if we read the whole file. We're just going to say that. Cool, so we can read tokens. We don't have anywhere to read from. We're going to support a file struct shortly. But now that we have an HBK vector, We can do that. So where do we want to get this from? Another thing to think about. I said this was going to be similar to Lua. Lua has dynamic name lookup. So maybe we don't turn this into a full compiler right away. I mean, if I want it to be a full compiler, embeddable but compilable, but also interpretable. I'm trying to think how far to take it in either direction. How easy do I want it to make it compilable? Probably very easy, which would mean no dynamic lookup, and we would have to include absolutely everything we want to reference at all times, which would mean the potential for having to do foreign declarations, right? So our standard library could not be implicitly included in the interpreter. I mean, it could, but it probably shouldn't for the compiled code to also be compilable. What I'm saying is basically, if we want to have this print function, I mean, I guess it could also just be implicitly included by the compiler, right? But this print function has to exist somewhere. Somewhere. And we're not we're not explicitly including it. So either we have like something like Lua where we have like local lib equals include, but that's not going to make sense. We're probably going to have an include or an import function or construct that imports a file or a library, and we're not going to do anything fancy with that. It's probably just going to put everything in global scope, right? So we'd have to have like our own standard IO or our own Hibiku, right? Hibiku. And if we're enforcing the Hibiku file extension, then we could just say import Hibiku and it can append it if it doesn't exist, right? So import Hibiku might just be fine, and that would give us the entire standard library of Hibiku. And that could be implicit in every function or in every file that doesn't explicitly include it, right? We're probably not going to support name mingling. We can probably allude to it in the compiler book. Right, I can't do absolutely everything with just one language. So we're probably going to avoid name mingling here and just discuss how you would do it if you needed to, and just keep this a simple one-to-one. Everything exists like this. Language. Okay, so we don't really need a dedicated like context necessarily. We probably still will have one for the purposes of sorry, just a lot of thinking out loud about what I want to get. Like the concept of where do I want to read tokens from shouldn't be difficult, and I really could just start with concept car and file path. And maybe we do that just to get the lexer started. But eventually we're going to want to know where to store those kinds of things. What dependencies does a file have? What is it relying on? For execution purposes, we'll want to have a state for storing that. So sure, for right now, we could start with file path and then change that in the future. So let's do that. New file, hbk lex.c. This wants to include hbklex.h so that we can implement this function. And this function is just going to give us a list of tokens. So hbk vector, hbk token, tokens, null by default. We're going to return tokens. Cool. And null. We've never included anything that gives us null. Well, that's going to be standard lib. Does standard lib give us null? Standard def. Standard lib would give it to us, but I think standard def is where it lives. Right. LLVM project. There's probably not just a defined null. Because it's in, we saw where it was at. Standard def null right there. Yeah. So, but standard def should give us null, so that's fine. That's all we need to know. So from this, we need to be able to read a token. We need to also have a file to read the token from. So let's start with type def struct hbk lexer. This is how I always do a lexer. We're going to have a single lexer state at the top here, and it needs to know some things, like if we're reading through an entire file all at once and not using a file stream, which we probably will be doing, then, well, yeah, no, that's fine. If we wanted to start interning strings and have copies of them that are unrelated to the lexer, we'll get to that when we get to that. But we will support that sometime soon. That'll be one of the first things we do, in fact, to test our like memory allocator and get a state in place. But for right now, we're not going to worry about that. We need a file name, which can just be the file path. So const car file name, like this. We need the current position within the file, which can be a size t. Does size t come from standard def? Probably. Standard def size t, yes. I don't like using size t, actually. Do we have a pointer diff t? Comes from standard def pointer diff t. Maybe I just use a regular s int64 t. And we grab standard int. I just don't like using unsigned numbers when I don't have to use unsigned numbers. So int64 t position. The position in the lexer. The current character index. Ooh, hold on, who's talking to me? Lots of people are talking to me. Okay, the current character index being read by the lexer. Current character index within the source text. Cool. Then maybe I do want to go ahead and set up a string and a vector, right? Because what I want to do with the source text is do hbk string source text, or just text, right? The source text being read by the lexer, for example. The source text being read by the lexer. HBK string. Because what we want to do is have an offset and a length, or not an like a pointer to the string as well as the length, so we can do easier checks with this position here. So we probably want to go ahead and create a string. We don't have to do anything fancy with strings specifically just yet, but I do want the type. If and def hbk string h define and if string type def struct hbk string hbk string, that needs a car pointer. It's a string. We should be able to write to it, but that's fine. Not that's fine. Yeah, we'll just call this data int64t count. And if it's a modifiable string, I also want to make it a capacity. And maybe we just make it a vector. So if I instead said include hbk vector and turned this hbk vector of car for data, then to do local include an allocator. The problem with hbk vector of data, if we want to include an allocator, we have to support allocators for the vector type, which I don't know that I want to do for something as simple as this. We will want to have a pool allocator, but I don't think we give a shit about allocators for strings. I think they're just going to use malloc and free. But then if we're interning strings, they'd all have to be string views, wouldn't they? Yeah, so they'll all be string views if they're interned. and they'll be strings if they're malloc and freeable. So we're just going to call HBK vector of car an HBK string like this, I think. And then we can use vector operations on. But then we can still have a type def struct HBK string view for const car data int 64, and that's it. If we're using int 64, then we need to include standard int get int 64. So does anybody need to know the difference between a string and a string view? I'm going to mostly explain it in these comments, but a string owns its data and is growable. I'll call it an a string which owns its data and is growable. And this one has the brief on it. We should probably brief everything, be consistent. A mutable view into an existing string. A string view cannot be deallocated as it does not own its memory. Here, look, not Dutch. I don't know, something like that. We can rewrite these docs to be dockable better in the future. So a string view is the data plus a count, and this HBK string is a growable, allocatable, deallocatable, owning version of a string. So for here, we really want this to be a string view, I think. I don't think we have any reason for this to be mutable. So HBK string .h. And HBK lex is already including vector. HBK lex should probably also include string because we'll want it for tokens. HBK string view string value. All right. Let's include in here standard int as well. Standard int, so we can have an int 64t integer value, a string value. We'll probably want floating point values eventually, soon eventually, but we can always add those whenever we get there. So now we have a text and a position within the text. We can say static car. This is not technically going to be Unicode supporting, so we're going to make our character an int to be slightly more prepared for Unicode in the future. So static int HBK lexer current. Okay. That's going to take in HBK lexer pointer L. And it's going to return L text data sub L position. We are not currently doing anything fancy with asserts. I'm not going to implement an entire assert right now, but what I will do is scaffold out the concept of an assert. So we'll probably want another internal header file, HBK internal API assert. Assert really doesn't need to be its own thing, but it might be. Diagnostics. Assert is probably fine, honestly. We'll just throw an assert in here if ndef HBK assert. H define HBK assert, and if not HBK assert. I want to do as little as possible, but I still want it to be kind of useful. So let's make a simple assert. Define HBK assert of a condition and a message with optional arguments question mark. the assert message probably doesn't need any arguments. So let's say condition and message. And for now, that'll do nothing, but eventually it'll do something. So we can do HBK assert, which we need to include HBK assert. We'll go ahead and wrap it in a do while so that I have to use the correct syntax here. The condition is going to be that L is not equal to null. Invalid lexer pointer. HBK assert L text data equal to null. Invalid lexer source text. And then assert that L. We don't really have to assert anything about the position here, because if it's out of range, we can just return 0. So if L position is less than 0 or greater than or equal to HBK vector count of L text data, no, we don't need a vector count. It's not a vector of L text count. Then we return 0. Otherwise, we return the actual thing, right? So that gives us a current character. Return the current character at the position. Return the character at the current position of this lexer. Lexer. I mean, the lexer is not it. The current character, if not at the end of the file, otherwise 0. Right, cool. So then we need to be able to initialize our lexer here. Lexer. The lexer is going to have a file name equal to the file path. It is going to have the source text, which we have to read ourselves. So we'll go ahead and write really quickly a static. The problem with HBK string view here is we need to know who owns the text, because it's not us. So this is where I wanted to have a context, an HBK context, or an HBK state. You could probably call it state this time to avoid any confusion. Instead of calling this assert, let's do API. This will be our internal highest level API. So in our API, we're going to type def struct HBK state, and this will hold all of the state for a certain execution context, loading context, program context, I don't know. Does anybody have any questions so far, by the way? I'm kind of just rambling on and I'm not sure what to explain because we're in the middle of the setup. So our HBK state needs to have vector of, so let's include HBK vector. So if we're ever including HBK API, we don't really need HBK vector, nor do we need string. We'll include string. If we include string first, vector will get included anyway, so that's fine. And memory. Okay, cool. No more questions. No Discord notifications. Nobody's asking anything over there. So instead of calling this assert, we're just going to call this API-H. Then our state here is going to have an HBK vector of some source file information. Probably. Oh, my finger looks funky. Very dry skin, apparently. I don't think this state necessarily needs to be public knowledge. This might be the first place where we have a public struct with a private implementation. So let's try that. For shits and giggles, we're going to try that. That's decent API design for somebody who wants to know how to write programs. Some things should be encapsulated. OOP is not wrong, but there's not everything. So hbk api.c is going to include hbk api.h, and then we're going to define our struct here like this. So struct hbk state. HBK state is going to have an HBK vector of source file, followed source files. We're going to declare HBK, we're going to prefix everything just to be consistent. Type def struct HBK source file. And it's going to have a const var file name, and it's going to have an HBK string text, the text of the source. So then we need to define a way to get and create that source. So let's say we need an ID. So I can type def int64t as hbk source ID. Now we can return a source ID. hbk state getter create source file, add source file, parse. We could just do the parser interface even right fucking here. But no, we probably shouldn't do that. We need a way to add, we'll just call it add file question mark. And then this could be where the parsing to IR happens, honestly. Interesting. Oh, this is not actually part of the API, probably. This should be in hibiku.h. That makes more sense. Because if we said add source from file, then we'd want hbk state pointer state and a const var file path. Then this can handle parsing and IR generation all in one, basically, and return to you an ID that you can use. So this can be our public API for that. So then in hibiku.c, instead include hibiku.h. So we have this API.c, which we do still want at some point to implement the assert functionality. Here, we want to include all of this and implement this one public facing file. It's going to do a lot of work. That's kind of funny, actually. We have two Hibikus. They're in different folders, though, so it shouldn't matter all too much. It'll just make looking it up slightly harder, so I have two files, but that's fine. In add source from file, we want to first iterate through all the existing sources, but we'll hbk assert. Assert, which is API. And API includes memory and vector and stuff. So hbk assert, the condition is state not equal to null, invalid state pointer, assert that file path is not equal to null, invalid file path pointer. Then we want to for size t, no, int64t I is 0, I is less than hbk vector count. We're gonna have to implement that in just a second, of state source files I++. We can then say hbk source file is state source files at that index. This is the other reason that we're having the vector be a pointer, because it's very easy to index things. Very convenient, love it. If stir compare, we don't have regular strings. Another lang. Well, look, I have a reason for it. I'm still working on Laie. I'm not quitting Laie. I worked on it earlier today and a lot yesterday. But I wanted to teach things, and I wanted to do blog posts on teaching a language and maybe turn that into like a chapter book series of here's how to implement a language, and Laie was not good for that. I didn't really want to explain things in Laie. I didn't want to use it as a teaching tool because it was intentionally kind of complicated. It's a language that I'm not making any concessions for. It's exactly what I want to do for design. Damn all the consequences. It's not a good teaching tool. So I went and was like, if I were to write a blog post, would I want to just write one blog post? Maybe. But what I might want to do is start working on this, a much simpler language, and write on that and turn that into a short series. Probably isn't very short, but a series of posts with a backing Git repository and stream archive of how to build a compiler in a very simple language for a very simple language, start to finish as just a reference material. So if I'm going to do that, I think that's what I want to stream, because I didn't like streaming Laie. Streaming Laie was, for some reason, kind of overwhelming, and I have no idea why, because it was a whole lot of experimentation. I have no idea what those emotes are. What the fuck is that? How did you get that? Anyway, point being, I wanted to stream more, and I didn't want to stream Laie, but I still really like writing compilers. So for now, one of the things I'm going to stream is this new language, Hibiku, which we're going to keep relatively simple. We're going to plan to write... well, I don't really want to typeset something. Eventually, I want to typeset something, but what I've got so far, I shared in the Discord already a little bit, is just I'm using Knob to be a static site generator. So I'm just turning a markdown file into an HTML file with pandoc and wrapping the output from pandoc in a little header thing that gives me a thing, which I showed off earlier, but we'll do it again. It was Python IDB cd dash. Yeah, I'm using Knob. Do you know what that is, or should I explain what that is? Python 3 HTTP server question mark. I already forgot what the command was. The public HTML. Yes, and then I can Chrome 0 chapter 1, not go to chapter 0. Right, so I've got this generating with Knob, which is cool, right? So this is what I've got an older version of Knob that I've made some small changes to that I'm using to build a static site. So this is just a bunch of things that don't go anywhere. But yeah, the output of pandoc just gets embedded in here, and I've got my own custom CSS for highlighting code. Yeah, so that's my plan, is I just want to write some blog posts, and this is a good thing to reliably write blog posts on. And I can write blog posts about whatever the hell I want. It doesn't have to be Hibiku. I could go write about Laie. I could write about whatever the hell I want. But I wanted to start a series because I've been wanting to write educational stuff for compilers for forever and just never gotten around to it. So starting this stream is my way of saying, yeah, I can write a simple language that I could talk about compilers in and reference the Git repository, reference the stream archive, eventually turn that into a chapter series of, hey, this is what the fuck's going on. Here's how to do stuff. So if people ask, how do I build a compiler? I don't have to be like, just start and see what happens. I can be like, go read my goddamn thing. Right? That's the hope. That's the plan. So anyway, back in Hibiku source land, we want to include string.h. Just to get strcmp, we want to compare file path to source file name. If 0 is equal to this, then return hbk source id of I. +1, I think, is what we want, so that 0 can still be an invalid value. We're going to go the route of interpret it in a VM first, like VM interpretation, but still build a language that is AOT enabled. Like it's a language you could still ahead of time compile. So I'm not going to go the route of like full dynamic typing Lua with all of its meta tables and shit. We're going to try to keep it a little simpler than that. Probably have type annotations, probably not support closures like I'm doing here for a little while, and just do all of the basics to get a language off the ground that can be interpreted easily with a register-based IR, but also still compiled without having to do a whole lot of work to get those high-level features down. So that's the goal. If we can get to the point where we can do closures in the interpreter and the compiler, then we'll have closures. If we can get to the point where we can have the primary data type just be a hash table and it not suck, then we'll do that. If we can get to the point where we want to define our own structure types instead of doing hash tables, then we'll do that instead. I imagine we're probably going to end up going the route of structures, but we'll probably still want to support a hash table at some point. I just have to know how to implement a hash table in a compiler, basically. So we'll see where that goes for high-level features, but I want to do both so that the educational material can be like, here's what a VM is, here's how you write an interpreter, and kind of go over what an AST interpreter might look like, but the primary interpreter would be a VM for a bytecode. And then also still talk about methods for generating code, like targeting C for easy access to instant, like cross-platform compilers, or LLVM if you want to either use the libraries or write your own like I did for Laie. Or maybe this will be a great time for me to properly learn how to do... Yeah, thanks. This is probably also the time I could learn how to write an assembly backend or an object file backend and actually do register allocation, because I still never fully learned that. So this might be an excuse, either this or with Laie, I'm not sure which one yet, to formalize and actually talk about a register allocator for a machine IR and turn that into assembly or something, right? So like a learning, the first half of this will be learning for you guys. I'll see if I can figure out how to explain things concisely and write these kinds of blog posts and do these kinds of streams and answer questions. And by the time we get to register allocation, hopefully I'll be able to do that and also learn something myself, right? That'll be a long way down the road, though. I'm not going to work on this probably as much as I am Laie, so but when I want to stream, this is probably what we're going to work on, unless I have something else exciting to do. I don't have as many bright ideas as Soding does, but I want to kind of turn into it Soding, just do whatever the fuck I want, have fun for 3 hours a day. So if you guys have project recommendations, maybe ping me in the Discord, tell me what you might want to see on stream, so I don't have to work exclusively on Hibiku. Yeah, it's only the parsing, but it's only the operator precedence parser too. It's basically nothing else. It's very high level everything else. Anyway. Yeah, there's a resources channel if you want to go post fun things, fun resources that you want to share with people. So here's our source ID. I think we want 0 to be an invalid source ID, but realistically, it doesn't matter. I think we're going to keep it simple and not confuse people and just say the ID is the index. So if it doesn't exist, we're going to make a new source file. So let's just, source file is this here. Can you in C23 do this without type specifiers? I don't think so. So just because we're going to do this. File name is file path, and text is going to equal source text. We're going to have to get the source text from HBK string source text here. This is going to be read file as string file path. And we don't need an allocator because it is an owned string, and that is fine. So then what we want to do is HBK vector append. We'll call it append. I could call it push. I'm going to call it append. But I like push pop. Do we want vector push? I think I want vector push. Vector push state source files and source file. Push the source file, and then return HBK source ID of HBK vector count state source files -1 to get the index. Cool. So then we just have to implement this and our vector stuff. So static HBK string. Read file as string. It needs a file path like this. And we're going to do ye old classic regular C standard library stuff. So let's grab std.io, .h, I like to be there. So from standard IO, we want a file, file. I just realized we don't have a way to report the file now. That's fine. We'll figure that out later. The file, we'll just call it f, is fopen file path for reading. If f is equal to null, well, fucking die, I guess. I could assert. That's probably not a good idea. So if I take in the state, we can report errors through the state. If I return the string, I can return the exit code out there. How do I want to do error handling for these kind of internal functions? That is a good question. Actually, also, HBK source ID equals this, return source ID, because we're going to want to put things in between this stuff. So. Let's just do HBK assert, and we'll replace these later. At least they'll be checked. F not equal to null. Would not open source file. Do error handle. Right. Then f seek 0 seek end, and that returns something. I don't know what it returns. It doesn't tell me what it returns. So we're just going to ignore it for now. Then we're going to say size t, or let's just cast it immediately to int64t, file length equals ftel, returns a long, that's fine. And we'll just explicitly cast it to int64 in case it's not. It should be on Unix at least. Fseek f0 seek set. Then we want to allocate the underlying buffer. It's an HBK string, so that's fine. We'll manually construct our string as a vector. Ooh, if we're using the vector interface, though, it's going to have a header. So we'll want to say two things here. Let's, just use the vector. So let's say car data equals HBK vector of car, to be explicit about what we're doing, is null. Then HBK vector ensure set count. Set count will do a thing. Set count data to file length +1 to include a null terminator so that it's usable as a C string. Right? Set count that. Then we want to read into data the file length has a size t. Size t of file length. 1. I guess we could just switch it to 1 this and then f. So that would give me everything I want in the vector. Then f close f. Then return hbk string. Oh, actually, that is all that is a string. A string is a vector, right? Forgot. So then we can just return string or source text like that. So we have a couple of things to add to our vector API now, right? Let me do it like that, maybe. So we need a vector count, we need a vector push, we need a vector set count, and vector get count, basically. So let's go do some things in vector.h. hbk vector, we need to type def struct hbk vector header. We're going to implement a very simple vector header here. It needs the include standard int.h. We're going to use int64 count and capacity. That's all we really need in the header. And then let's do something here. We want to implement void hbk vector ensure capacity. This needs a void star to the vector address to the vector, I think, right? Vector address. Then we need since it's a void star, it should be this. Vector address. Then we need int64t element size. Then we need int64t minimum capacity. This we're going to implement in hbk vector dot c. Include hbk vector dot h, and we're going to implement that here. In here, since we're in an implementation, we can actually also import API to get hbk assert that vector address is not null. Invalid vector address pointer. hbk assert that element size is greater than 0, invalid element size. And the minimum capacity should be greater than or equal to 0, invalid vector minimum capacity. If the minimum capacity is less than or equal to the thing. So let's get hbk vector header pointer. That's going to be hbk vector header pointer of vector address. Can I do that? I don't remember how I actually got there. I think that works. Vector address -1. So then we can say if minimum capacity is already less or equal to header capacity, just return. There's nothing to do. The other question is really whether vector address contains null. So if it contains null, then should, okay, so we wanted this entire function to just work, but if this is null, so we probably want to go ahead and create a wrapper around getHeader that returns null if the vector is null, but that's probably also a bad idea. How did I implement this? That's a good question. Let me code laye include lcads.h. Let's just open this up because we have our header here. We have the reference to the dynamic array, the element size, and the required count. So this is called maybe expand rather than ensure capacity. I think I like ensure capacity better. Yeah, that's fine. So when I say get header, that's what this is, and that's fine. Count and capacity is v, oh yeah, so it just does it like that. So then in my implementation, if it doesn't exist, we allocate a new one. Oh, it's simple as that. Okay. That's about what I expected. So we want to say if minimum capacity less than 0 or is equal to 0, we probably just want to return, do nothing. Then we have access to the header here. But really, if, let's declare this up here, and then if vector address is equal to null, we need to allocate a new one. Else, then the header just becomes this. We already have it allocated. If we have enough space already, don't do anything. Null doesn't exist. None of these include null. Include standard def.h. Okay. If this is null, then we want to say header equals malloc in standard lib. Malloc. What we want to do is size of header, like that. I'll do size of header plus element size times minimum capacity. And so semantically here, the minimum capacity probably shouldn't be smaller than a certain value. So let's say if minimum capacity is less than HBK vector min capacity, which we can define, then it should be equal to min capacity. Let's define this as like 16 or something. You always get at least 16 elements. We can change that later. So then element size times the minimum capacity. That gives us whatever the hell we want. Then we have void star. Data is header plus 1. Then we can probably just memset. We don't have memset because it's in like what, string? String.h to get memset data 0 element size times min capacity. As, is that a size t? Probably is. Yep. Size t of this. That gives us a nice 0 for our thing. And we want to also say fucking HBK assert header not equal to null and more lam lol. Header capacity is minimum capacity. Header count is 0. And then we memset the rest of the data to 0. Then we just return data. Right, we don't return data. We say vector address equals data. But then if we have a header already and the minimum capacity, whatever, so if we need to reallocate it, we then want to say int64t new capacity equals header capacity, while new capacity is less than minimum capacity. New capacity equals 2. Then we can do some things. We're going to say header equals realloc, because we have access to realloc, so that's fine. Header with the new size. The new size is going to be size of header times the element size plus the new capacity. Then we can grab data again. So we're going to double assert that header is not equal to null. And vector address becomes pointer to data again. Which shouldn't technically matter, but I think it does, yeah, because we're reallocating header. So header is going to change. So vector address becomes the new thing. Data plus equals whatever. We need to then memset the original count. So let's grab int64 original count equals header count. Then we want to memset data plus, which we can't do. We need to say car pointer of data plus element size times original count to offset ourselves further into the array. Then set it to 0, and it's going to be element size times our new capacity minus the original count to clear the rest of the data, right? So then here, header capacity equals new capacity, like that. And now we have a vector. Slightly more verbose than our last one. We're doing a couple extra steps to assert things and set memory and stuff. So that should be all we need here. Then we need to use this to implement. Let's make it minimum like fucking 64. Every vector should have 64 elements. That's a big ass thing actually, but 32. 32 is a happy middle ground. Now, in hpkvector.h, we can implement some of our fancy things. Why is this file not happy? I don't know. If I close it and reopen it, is it happy? I think it's happy. So what we're going to do to implement some things here, we need to define hpk vector get header of v, we're going to call it v for vector, as a function macro that is going to return hpk vector header pointer of v minus 1. That gives us the header. With that information, we define hpk vector count of v as v and get header count or 0. And we say capacity as the same thing, like that. Cool. So if there is a header, or if it's not null, get the header, get the count. If it is null, return 0. Same thing for capacity. So we then want to also say ensure capacity is fine. Let's do define hpk vector set count of v to a new count. To do this, we're going to say do while 0, force it to be a no returning function like macro. So do hpk ensure capacity and then set count. So we're going to do this and this and we're going to say HBK vector your capacity reference to V. We need a size of star V, and minimum capacity would be, right? Ensure that we have at least count. Then we need to increase the we need to then say count equals count. The fact that this is called count is probably a bad thing. So we'll call it C. So then this becomes this. Well, 0, format it. Okay, so now our set count is going to ensure we have the capacity to set the count and then set the count. So by ensuring capacity of something, we should always have HBK assert, which is not included. So although we can't include HBK API, so we can't do assert. We're going to rely on this always returning valid data. Right. So then at the very, very end here, HBK assert vector address not equal to null, failed to populate vector data. Like that. Right? That makes good sense. So that sets the count. The next thing we want to do is push. Define HBK vector push of V an element. Do while 0 do a thing. The thing we want to do is ensure capacity of HBK vector count V plus 1, at least one more thing, then V sub vector count V sub vector count equals E, and then count plus plus. Right? 1. So this says, make sure you have at least one more space. At the end of the array, set it to E, the element, which I guess means we should do that. And then increase the count by 1. The capacity will change here, but the count won't. So that is probably good. There we go. So that's vector push. We have vector push, we have vector set count, we have vector capacity, count, and get header. So back in Hibiku.c, we're using vector count, vector push, vector set count. Okay, so then basically what we want to do here is HBK assert that source text is not null. Failed to allocate string data. Then we also want to assert that HBK vector count of source text is equal to file length plus 1. Correct count for string data. Cool. So then fread source text 1 length, and we've allocated plus 1 to null terminate the string. So I'll also then assert that source text sub file length is equal to 0. Source text string was not null. Right. So then we can return the source text. So we've probably got some build issues. This build issue is HBK version. And doesn't like that either. Oh, because I made them fucking... Yeah, I need to use HBK stir again. We didn't do that. HBK stir and HBK stir again. Now, how many errors do I receive if I type make? Only a handful. int64 in hibiku.h. So in hibiku.h, we need to include standardint.h. Then we need passing argument 1 to ensure capacity, incompatible pointer type, source file pointer to avoid pointer. Should just work, but I guess it doesn't. So in vector.h, we're just going to pass void ** like this. No, not there. Here, void **, void **. Format. Make nothing to be done for all, because it's not dependent on the header files. That's annoying, actually. Okay, so if I Hibiku, still prints 1.0. Hibiku 1.0. Hi, cool to catch you. Like, yeah. I should be live for another hour or two. I am on Fedora. Yes, this is the version of Fedora with KDE as the desktop environment. Ah, fuck. How are you today, Joy? And what was I doing? We need to be able to test something. So let's... That's good. I'm tired as hell, but I'm programming anyway. We need to be able to create a Hibiku source file. So we have this, but let's say hbk state, hbk state create with nothing fancy special just yet, but we're going to create it. We're going to create it here by just hbk state. State is malloc size of state, return state. We will hbk assert that state is not equal to null. Ramlol and return it. Said malloc. We should really calloc to 0 it. Okay, so we're calloc right there. Return the state. Do nothing fancy with it at the moment. This will be nulled out. So let's, step 1, hbk state is state create. Easy. And for correctness, let's also declare it as taking void. Okay. So hbk state create. hbk assert state not equal to null. Failed to create state. That's going to leak memory, but that's fine. If I make, we have two things. calloc doesn't exist. Have we not included standard lib? Okay. Make. Too few arguments to calloc. Because I need to do 1, yeah. Okay, and hbk assert doesn't exist in Hibiku. Does not, because we need... This should have the assert, probably. I mean, the assert is mostly an internal thing, so we don't have to assert here. I'll figure out if we want to expose Cool. So then we can just, for shits and giggles, fprintf standard error mod p state and make sure that we allocated something. Make Hibiku. Cool. There is in fact a pointer there. Great. So then we can hpk state add source from file state examples hello Hibiku, and that'll be hpk source id. Source ID is this, right? So that's how we're gonna manage handling things to Hibiku here. It does print something. It does not crash. So now we need to be able to get to the source text and print it. HBKey string. Problem number one. Not really a problem. We're not exposing HBK string. It is a internal to the compiler thing. So that's probably fine. I think we said earlier that the API should probably not expose that kind of thing. So I can say const car hbk state get source text as a C string. We've ensured that it's a C string already, so we should just return the data. hbk state hbk source ID source ID. So then we can go into Hibiku hbk assert state not equal to null valid state pointer assert that source ID is greater than or equal to 0 invalid source ID return state source files subsource ID dot text, which should already be a C string. And then while I'm here, I'll go ahead and also implement get source name. We'll just return name. It's called file name here, but it really should be just name. Name. That's different. We're going to replace that in just a second. I think that's fine. Okay. So then source name also needs to be declared out here. So then we can print f standard error mod s new line mod s new line hbk source name state source ID and source text. Make Hibiku. So there it is. It is examples hello Hibiku, and there is our source text. Cool. It is null terminated. We haven't fucked anything up. Let's git AC implement high level state file management. As well as strings and vectors. Because I forgot to commit when we did vectors and strings and stuff, so let's just git push that. I'll try to be a bit better about committing things when they actually matter. But there we go. We've done the bare minimum. Well, not the bare minimum. If we were doing the bare minimum, I wouldn't have done any of this. The bare minimum for actually managing things kind of correctly. So next, let's go back to the Lexer and change this read tokens thing to take in hbk state and hbk source ID, which means then that I need to include hbk or hibiku.h because that's where those live. Those live in hibiku.h. So now our we haven't even started implementing the Lexer yet. Thought we did. I guess I deleted it? Question? No, it's right there. It's above here. I'm stupid. I'm blind as hell. So we want the Lexer here to cache the source text as a string view. We're going to hbk state to grab that and hbk source ID. So that's what we initialize this shit with. State is state, source ID is source ID. Easy as. In order to get the text, lexer text is going to be state get source text. Ooh. Interesting. Because here's the thing. I said the public interface was going to return to us a C string, which is fine. I really want to get a string view just straight up, straight out of here. So maybe that's not a good idea, because I don't have access to the internal data structure for source text. I could just call strlen, but I don't really want to do that. We know it's null terminated, so instead of relying on the length, I guess we could just pre-compute the length. I just really don't want to if I don't have to. That kind of makes it pointless, since it's internal. It's not internal. Ooh, okay, what I could do though is get source text as view for state. And something that I didn't think about is I could just fucking, in API, I could say include Hibiku, because it's not including the API anywhere. Then HBK string view, get text as view, HBK state, HBK source, ID source. God, my fingers are fucking not fingering. So then in HBK API, well, we don't need to implement it here. We want to implement this back in hibiku.c. Right, so what we're going to do here is exactly what we did here, but we're going to return HBK string view, and we're going to say dot data equals the text, and dot count equals vector count of the text. So that gives me a string view. Still nothing in HBK API, but it'll have the assert and diagnostic stuff probably. So Lex is then going to say state source ID, and it's going to return to us null. Okay. Does that still work? Yes. Okay. We compile successfully, so it found it. What I want to do now is not do this. We are going to internal to this. When we say add file, I'm going to go ahead and start trying to parse. We'll start this with HBK vector of HBK token, tokens equal to HBK get tokens, HBK read tokens from file. We need to include the lexer, basically. HBK lex. Eventually we'll remove that and just include the parser, probably. HBK read tokens. Does just do state source ID. Cool. So we're not going to do anything with the tokens. I'll just void tokens and make. Okay, it's not dying. So we're calling it, it's getting stuff. That's good. And the reason that I want to just do all the parsing and stuff in here is anytime you're adding a file, that's what you want to do. So we want to give you a source ID that just immediately gives you all the information about the source file, which means, of course, that as we do things, we're going to want to populate this with things like, for example, we could do HBK vector of HBK token tokens. We could just go ahead and say source file, which is not a pointer, which should probably be a pointer, because we have to push it. Yeah, so if I just said, for right now, this is kind of temporary, because we're going to move this elsewhere, I think. Maybe not. Sub source ID dot tokens equals that. That should still work. Hello, Hibiku, yep. The only problem with make is I don't have it depending on enough stuff, really. So I'm going to go into the make file and grab headers. It'll be libh as well as include hibiku.h, which really should, I guess, just be another wildcard for include. So then we can say that all Hibiku depends on headers as well, and then I can get a full rebuild out of that. But oh shit, actually, because this, yes, I want to use this more educationally, so I wanted to support at least a makefile because it's a lot shorter and pretty quick to explain, and I don't want to teach people what the hell knob is. So if I'm going to write about this, then I don't want to write about how to write a 100-line C build file, right? So I'm supporting it because I like it, and I'm probably going to use it most frequently, but I'm using make right now just to make sure that it covers all my edge cases. And here's problem. I want Hibiku to depend on headers, but I don't want to do whatever the hell this is. I guess I have to inline it so it can depend on headers but not build the headers. So then if I, that still works. Cool. So now if I go make changes to the headers, it will still rebuild, and I won't try to accidentally compile the headers as C files. And I don't know make well enough to know if I can easily customize this. I'm having it run GCC right here because I want to have knob building Clang, and then I can run both in parallel if I want to without having to do too much configuration. So right now I think knob is also using GCC. Ooh, no such file or directory. It doesn't like that. Weird. Yeah, so knob is also using GCC, but I'm probably going to reconfigure it to use Clang in just a second. So include Hibiku. This should be in the include file path is the problem. And it's working with make. So am I just not including the I might just in knob not be including. Yeah, I'm not. So knob command append command I include. That's all we're doing. So knob wasn't even set up properly. So I think the way to get knob to run Clang is the way I have it set up. I can just rm knob and then Clang knob C, and now it should be running Clang. So if I knob again, still running GCC. Should be running my custom Clang, yeah. Interesting. Because what I did in knob here is if GNU-C is defined, but I guess Clang could also define GNU-C, so maybe I want to invert these conditions and do... Well, that's not quite how I wanted to do it, but... so if I do this, and then do the same thing up here, this is wrong. That needs to be there. Cool. So if I do that, then rm knob, Clang knob. Now it's running Clang. Okay. And then our make is still running GCC. Well, I mean, you can't see it now. If I rm Hibiku and then do it, GCC. Okay, so now I have a build running each, which is good and dandy and fine and good and dandy and good and fine. So if I'm running with Clang, what I want to also do here is f sanitize address to get the address sanitizer in here, and that probably means we're going to have some leaks. So, oh, see, it's running CC here. That's why, and CC is GCC. So it's recompiling itself with GCC, and that's why it's not sticking to Clang. Okay, so the order here doesn't matter. What I need to do is get a custom rebuild yourself. And then we can say, here we are. So we're gonna change this a little to just also do if win32. I don't really need to know if win32, because all I'm gonna do is if this, if GNU C, if Clang, if MSV Receiver, fall back to CC, right? So then, don't care about that. We're just going to define it here, and then include knob. Right? So then up here, we can also just define CC as Clang. We can define GCC. We can define CC, and we can define CL.exe. Right? So that gets rid of this. And we'll still do the same thing here. I am going to reorder these again to match the rebuild yourself technology, just so it's easy to keep up with. And then everything will include. Now this doesn't support the other compiler, MSVC. I don't know what it supports, so that's fine. Knob, so Clang O knob, knob C, knob, still GNU. RM knob, RM Hibiku, Clang, no. So I guess Clang is defining GNU stuff, right? It has to be. So I do need to reorder this stuff again. God damn it. So if elif, so then if elif, right? Yeah. Because if Clang is defining GNU C, then I have to check Clang first, because GNU C is almost certainly not defining Clang. I don't know why GCC would ever do that, but yeah, but so long as it's building with Clang, it should still support the same features that Clang does. So if we're building with CL and it happens to not be building with Clang, then we'll rely on CL stuff, right? But if it's defining Clang at all, I'm going to use Clang's features even on Windows. So it should be fine. Should be. So now, if I Clang, oh knob, Clang. Run it again, still Clang. Cool. And if it has to rebuild itself, hopefully it's also still just Clang. So now we've got knob and the makefile both up to date. They're both doing what they're supposed to be doing. We can start writing a lexer, I think. Let's go back to our lex.c. So we've got the source text. The position should default to 0, so we don't have to set that. So now we just need a handful of helper functions. So this one gets the current car. Static void hbk lexer advance is what I'm going to call it. hbk lexer l moves the position of this lexer to the next character. And for right now, all that's going to do is, well, one, assert that the Lexer exists. Two, assert that there is data in the text. Then we're going to say if L position is greater or equal to L text count, then L position equals L text count. Because we're also asserting that it's null terminated. If L text data sub L text count does not equal to 0, not null terminated, which I should also be doing up here and probably down here. Assert Lexer text data should be not null terminated, and it should not have null. Lexer text data, cool. Lots and lots of asserts. We really then, since these are static, can only be called when this is initialized here. I don't think we need either of these asserts. So we'll keep it a little simpler. I'm not going to assert as often as I normally do. So then here, else L position plus plus to the next character. This does not currently support Unicode. We will do Unicode eventually, but for simplicity, no. HBK read tokens is then going to want to call into static bool question mark. Again, we haven't done diagnostics yet. We probably always want to return a token, so HBK token, HBK Lexer read token, which is going to take HBK Lexer L and return a token, and the token could be unknown / invalid. So currently we've got unknown as the first thing here. We probably want this to actually be invalid, to say, hey, we didn't actually read anything, or something bad happened. The default state should be it's not a real token. So yes, basically what that means for us is we want to HBK token is empty, and we want to return the token. Results the token. So then the next thing we want to do is, for as long as we're not at the end of the file. Now, here's the thing. The way that we're doing advance only cares about the count. So we can have null bytes in the source text. So I think we're probably going to just technically accidentally keep supporting that. Static bool HBK Lexer is ELF. HBK Lexer L. Return, well, make sure that the Lexer pointer is valid in all cases. Return L position is greater than or equal to L count. L text count. If ever we get beyond the bounds here, we just return that the bool. We haven't included standard bool, but we're in C23. Bool should be a keyword now. If I try to compile this, does it compile? It does. So this is purely because our compile flags aren't. So this is, yeah, it's the IntelliSense. Settings, I guess that's going to be in here. C standard, default standard, GNU++, no, that's the CPP standard. I'll set that to 23 as well, but we want C23. Okay, so that should update. If I reopen it, I close the whole thing instead of not closing the whole thing. Cool. Still undefined. CPP, that's not 23 at all. It's running through Clang. That's fine. I hate that, but that's fine. Now it's fine. Okay, yeah. Cool. Then, handful of things. We are very soon going to want to be able to report diagnostics about tokens. But for right now, we're just asserting. We should probably start writing the Lexer first before we worry about diagnostics. I can at least set up the API for diagnostics, maybe. I'd probably just throw an HBK assert and make it a to-do. So let's make a couple of new macros in the API. So we have assert. Let's just say define HBK to do as a message that it evaluates to HBK assert false message. And I can say to do colon space message, right? That gives me a to do. Then we can come into HBK Lex and we can start doing to-dos. We can even use that in hibiku.c because we have a to-do up here. We have this HBK to do. Well, that's the assert. So actually, no, we don't, because we still want this to work even though we haven't to-do'd it. To-do local handle errors for file not existing or being unopened. Other reasons. Okay, so back in the Lexer, we have a token. We have not associated a location with the token just yet, so we probably still do want to go do that. And that is going to be either within the API or at this level here. The question is, how much do we want to expose to the user? And I'm going to say probably not much for right now. So I don't think any of this wants to know about locations. I mean, the state does, but it's internal to the application. We will want a public-facing API for reporting errors if we're allowing native functions to be embedded for interpreter purposes. They will eventually want to be linkerable in that case. Right. I guess that is kind of... No, that's fine. Yeah, no, that's fine. Okay, so we'll do it in hbkapi.h. In here, type def struct hbk location. That is a source location. So we want an hbk source ID. We want an int64 offset. I think that's it. Maybe a length. We probably want a length. I have never really included a length in my locations recently, but it should probably have a length. That would make error reporting and rendering much easier. Don't have to guess the length, don't have to recalculate the length. So yeah, we want the length of the location. We want the offset of the location. And we want the source, wherever the hell the source is. Okay, that's good, that's good. We have a location. So let's go into lex.h, which needs to include hbk API. Then we need hbk location. Then I probably, for convenience, ooh, just a second. Okay, should be back. Had to try an avocado. 50-50 on the avocado, I'm not sure how I feel about the avocado. So I need an API for creating and manipulating locations. Doesn't have to be very... I mean, like, I can't just call it HBK location. I could just call it create. Create to me implies that we're allocating something and we're never really allocating a location. But HBK source ID, int64t offset, and int64t length. The only reason I might want to do this is because we're creating a lot of locations. And if we're creating them in line, we get the really simple inline struct constructor syntax, whatever the fuck it's called. If we're doing it out of line of a declaration, we have to include this before it, and a function call probably just makes that easier. So I'm going to come in here, say, this can go in the API, that's fine. API.c, return HBK location. This is the syntax I was referring to. Because then we have to include these names. We don't have to, but I'm going to include these names. And I just don't want to have to do that all the time. So that gives me a location. Okay. So then in the lexer, we're just going to say token location equals HBK location create from L source, oh boy, source ID L position and 1. Hello, Adam. How you doing? We're making a new compiler so I can try to teach people how compilers work. And we're just getting things set up, and I don't know what to teach just yet. I'm just setting up a lexer. I'm going to go through and probably add a bunch of doc comments. We're going to try to make some blog posts / chapter reading material about how the fundamentals of compilers and interpreters work. So I wanted to actually start working on the project so we have something to talk about in that reading material later. I'll probably do some writing on stream eventually, but I'm planning for right now most of that to be done off stream because I'm figuring out what I want to write about. So we're making a language called Hibiku. It's going to look something like Lua. Hello, fellow computer developer. And we're going to try to interpret and compile it. So there's some high-level features from a language like Lua that we might not be including, at least for a while, until I figure out how... what in particular? Because if it's just the language dev, Laie, the programming language, is still very underway and compiles. So if it was just the language compiler part, then yeah, I'm still doing that. If it's the teaching part, then yeah, I hadn't gotten around to that until now. And it'll probably still be a very long journey, but I was in the mood to stream it, the setup. So we're streaming the setup. And I'll try to stream as much of this as I can. I'm much more willing to stream Hibiku than Laie, because Laie is very complicated, and I'm not using it as a teaching tool. But if I'm streaming Hibiku, then I am very in the mood to use it as a learning exercise. Yeah, no problem. If you guys want to help me figure out what to actually write, what you need to learn about, like, you know, I have not been a beginner for a very long time. That is not a brag. That is an, if I'm going to teach, I need to know how to teach beginners. So if you guys want to hop in the Discord channel, I'll be probably talking a lot in development, and maybe I might even create a channel here for like blog post discussions. I don't know. Right, if you guys want to come help me write this material, proofread, give me feedback, whatever, join the Discord server. I'm going to keep talking a lot in there, and I'll stream whenever I can. Yeah, links in the stream description, video description. You are more than welcome. There's lots of smart people there who will answer your questions, not just me. But that's where I work on Laie. If you haven't seen me post a video and you're not in the Discord channel, I've been talking about Laie a lot. Even just yesterday, we were talking about some future features for like how fucking this shit works. Anyway, yeah, go join. It's fun. Oh, and I guess the important part for stream viewers is I will tell you when I'm live. I don't have a new thumbnail for this series because I am on a new system that doesn't have the software I'm used to for making images. So that might go in off topic. How the hell do I make images on fucking Linux? Because I don't know how GIMP works and I'm stupid. Anyway, we were reading tokens. We have location information. We're not going to report diagnostics just yet because I want to put a little bit more thought into that, and it's going to take a second to do. An actual diagnostic is pretty simple, but I want to be able to support like good diagnostic rendering in the future. And I want to have like a generic-ish kind of result type that we can wrap diagnostics in without it being so complicated that it's hard to write about. Right, I really want to include in my writing some of the conveniences that you can do with C macros without being a complete bastard about it. And one of those things that would be really interesting to talk about is like a monadic result. Right, because we're doing generic vectors here through macros. That's the only way to get generics in C is through macros, at least at the type level. At the function level, there's the generic thing to give you generic overloading of functions. Right, but that doesn't work for types. So this is how you get generic types. So if I wanted to have nice, easy to use monadic parsing or lexing or a monad for storing, right, the result of something or a diagnostic saying it didn't work, I might write about how to do that and see why it's useful. We're going to definitely write about this vector as part of like its own chapter, writing a vector, a subchapter or something. The string at the moment is just implementing a vector, so I'll probably have an aside about what a string view is and the fact that we're writing strings in terms of vectors, so you can just read the vector chapter to know how a vector works, and we'll get into specific string operations later. High-level things that I'm thinking about. But I definitely want to implement... Well, okay, for the purposes of this parser, I don't actually think we need a result type. I need a result type for Laie because it's a complicated parser. But honestly, if we keep the grammar of Hibiku really simple, we don't need a result type. So maybe I won't write about that. I might mention in passing that more complicated parsers could probably benefit from it and suggest people read about monads. And I'll probably do a blog post on monads because, God, everybody thinks monads are so complicated, but they're really not. So I can do a monad from like a C programmer's perspective, monad from OOP perspective, monad from whatever, like, right? Because they're very useful. So I'll probably post about those, but they probably won't be in this series now that I think about it. Anyway, we're writing a lexer for Hibiku. How long have I been streaming? We've been streaming for almost 3 hours. What have we done in 3 hours of work, I wonder? It says almost 3 hours. Live for... Really? Did I start at like 9:30? Wow. Interesting. What I wanted to do was fucking clock. God. We've already written 1,300 lines of code without comments. Already kind of a lot of comments. So hey, that's not much. I think Laie is in like 7,000, so it's not even that much more. Yeah, I'm actually curious. Clock of Laie. Were you with like the 10,000s yet? Well, that doesn't really. So, can I do multiple directories and say source and Laie lib and Laie include? Can I do that? There it is. Yeah, it's almost 12,000. 11.5. We're already a tenth of the way to Laie. Cool. And if I do knob Hibiku, then we'll get the output from Hibiku as well. There we go. Where are we at status-wise? We've written some more things. So git add makefile, git add knob.c, git commit with a message, update build systems, then git diff lib hibiku. I think this is just the as view plus vector of tokens plus okay. Yeah, so Lex and API. Git add. What do we want to call this is the question. So git diff lib hbk api.age will tell me what I added. So I added location information. Then Lex. I think that's all I did was add location information here. Okay, so then in the C file, that's where we started implementing read tokens. Git AC implement entry point for parsing. Let's see. And I'll sync those commits. Okay, by the way, if you guys did not know already, you can view the source code for this. It's in the description on my GitHub under Hibiku. I don't think I have it pulled up there. I don't. So next, we want to start implementing some tokens. What we're going to do here then is just switch on HBK Lexer current character. In the default case, we're going to technically do nothing. I think we're just going to say HBK advance first, then, no, not first, we're going to say token string value shouldn't really be anything, but it's a string view, so we can do whatever we want. Equals, I don't have a function for making this easy, so lie is the other language, HBK string view data equals L X data plus L position. I'll turn this into a function to get a view from a range later, but actually it's going to be very useful, so I'm just going to go ahead and do it. Token location doesn't change at all, so we can advance. So then we're going to have static HBK string view, HBK Lexer view from location, HBK Lexer L, HBK location. And that's going to do return HBK string view, data is L, data plus location, offset length equals dot count equals location length. Right? There we go. So then here we're just going to say token string value is view from location L location to do local just fucking report invalid character with diagnostic API. Right. Then we want to view all of our little characters here. So let's go first, before we start actually reading them, let's go into source from file for int 64ti equals 0, I is less than vector count of the tokens that we read, I++. We're going to print f standard error. We're going to see our not quite fully implemented tokens. What that's going to be is probably just we can do the kind actually. We'll have to implement getting the kind. It's invalid, so we're just going to write invalid for now. But and then we can new line after the string. If you've never done printf in C with length strings, like strings with lengths instead of null terminated strings, you do the count of the string first followed by the data, and you use %.s, and .star means the length is coming in. So we're going to say we need HBK token so that we don't have to type this a whole bunch of times. Tokens sub I, that'll give us an HBK token. Right, yep. Then we want int token location length, and really it should be int token string value count to be pedantic, but it's the same thing. String value data. So all of them have string values for right now. Eventually that won't be the case, but we're going to assume that it is so we can view them. So if I go back and do knob, I should have just typed it again, knob Hibiku, we have a warning. Mod.star_s, this should not be an int. Cast. Okay. So now we need to go back into the Lexer and start reading those tokens. So we're returning this array of tokens while not HBK EOF, basically. Lexer is EOF of Lexer. We want to say HBK token equals Lexer read token, Lexer. Then vector push tokens token, and that's it. There we go. A bunch of invalid characters as tokens. Function create header. Boom. So then the next step is going to be either just read all the actual things and always store a string value, or every time I go to say it, my brain drops it. I say something else, it comes back, and I go to say it and I drop it. Or we implement the enums for these things into string them. We're going to need to implement the enums anyway, so we'll probably just do that first. In the Lexer, we have this invalid thing. What we really want is a bunch of different kinds of tokens. What we really, really want is to not have to retype all kinds of things all the time. So we're going to automate something here. This is called an X macro, if you've never heard of it. So I'm going to probably link here X macro style, X macro for token kinds. And we'll go look up X macro and see. I mean, there's a Reddit post here. That's probably not. Is there a wiki on X macros? I thought there would be a Wikipedia entry for X macros somewhere, but basically, that's not what I want at all. I could have sworn there was a Wikipedia entry for X macros. Wikipedia, see X macro. Come on. If anybody's actually seen that Wikipedia article, let me know, because I'll totally link to it. Otherwise, I want a really simple text. It does. I just want... I just want a text post I can link to. I know I've seen a Wikipedia entry for this. I know I have. X macro. Yeah. Yeah, this shit. Why didn't this fucking come up? So we're just going to link to this Wikipedia article, assuming that Wikipedia doesn't die, because despite this, at least they're not begging for donations anymore. I have donated to Wikipedia, by the way, at least twice. I have donated a small amount to Wikipedia. So this thank you is for me, not for you, unless you have also done that. Anyway, X macro. So what we're going to do here is we're going to say HBK token kinds of X. We need to define it. Define HBK token kinds of X. And then we're going to say X of something. We're going to start with just identifier, and we'll worry about anything else later. Because what I'm also going to do is use ASCII codes for single character things. So define, well, I say I'm going to use ASCII codes. If I'm using ASCII codes for simple characters, yeah, no, I think that's fine. Because anything, even when we get to Unicode, we're not going to be using single Unicode characters for anything fancy, probably. So let's define X of, we'll just call it N for the name, to be HBK token concatenate the name, add a comma. When we're done, we undef X, and then here we just say HBK token kinds of X, right? There's our formatting. And that's all we got to do. But what I'm going to HBK token multi-byte start. So the next one is going to be 256, which requires 2 bytes. 0 to 255, 256 is the first multi-byte. So there we go. That means that everything from 1 to 255 is available for single character, single byte characters to be used. And we will probably want to include a lot of them in here manually so that the compiler doesn't throw warnings for invalid enum values. But for now, this is fine. And then the other thing that we want to do is provide an API for grabbing the name of a token kind. So HBK token kind get name. HBK token kind. This will brief, which should probably be here as well. Brief. Get a constant C string name for the token kind. And we're going to implement this in HBKLex because that's the header file that it's in. We'll implement it before we even get to the Lexer. We're going to, if, I guess, just switch on kind, case token invalid, return in HBK token invalid. Now we could, here's the thing, we could include the prefix here, or we could just call it invalid. I think we're going to do that. So then we can say define X of N as case HBK token N return N, like that. Then undef X and HBK token kinds of X. Why not? Perfect. Then default we can do at the end because it's going to actually take up a bit of space. We are going to do a fancy schmancy. We're going to say car of 256 times 2. And that's going to be characters, which will be 0 initialized. Then we're going to say, this should be static. There we go. Static car, whatever. If kind is greater than 0 and kind is less than 256, we're going to do a thing. And we also want a static bool characters initialized equal to false by default. False is not going to be a constant, is it? It's undefined. What the fuck? We just but 0. Because bool is defined. This is a keyword. It is not defined to anything. Why? Wait, false? Okay. If this else return unknown, so that we know something fucked up. Alternatively, we could just assert false unhandled. HBK assert false. We could assert this actually, and then just do our if is initialized. So HBK assert right here. Invalid unknown HBK token kind cannot stringify it. So then if we didn't initialize the characters, we're going to go for int I equals 0, I is less than 256, I plus plus. Then we're going to say characters sub I times 2 equals car I, like that. Then we're going to return a reference to characters sub I times 2. So once during the entire initialization of the program, or once the first time we call this, these will be initialized to 0, and we need to set that to true. Fucking 1. It's going to initialize this the first time we hit this code, because static is only initialized once at the start of the program, and this memory is the same for every subsequent call. So once, we're going to initialize all these characters as null terminated strings of their own characters. And this is not I, it is int of kind. I don't know why I want to copy it, it's int of kind. So for every single byte character, we're going to store that character in this long string, and the character after is already 0 initialized. So at index whatever less than is times 2 will be index, because every other character should be a 0. So if we do this, we'll get a 0 terminated string for the less than symbol or something, right? So then we don't have these big clunky words for tokens that are just single characters. We get character literals for characters. I don't know if I explained that well off the top of my dome, but that's how we're going to report character names for tokens. So then we're going to quickly update hibiku.c to, instead of reporting invalid, report the kind of token. So let's say first we're going to, let me copy this. We're going to first say token kind get name is going to be, I've called it get name. It should probably be toString, but that's going to be token kind. And then we'll do something with this in a second. This is toC string. We'll just call it toC string. That makes a bit more sense. Then if, and only if, this count is non-zero, we're going to add this, and we're going to put it in brackets so that we can tell what it is. So in brackets is going to be the string value. So then this will be the kind. It will then be the location information. It's mod LD and as a length, I guess. So technically, I want this, but that's fine. LD. So that's going to be token location offset, token location length. And then we'll do another one with the text. So I don't need this. I need my console back. Hibiku. So there we go. Now we've got the text value, as well as whatever this is. It still says invalid, but it's not hard-coded anymore, right? So now, the next thing that we want, let's go ahead and get add token kinds and stringification. Sure. I'm glad you think it's cool. I think all this shit's cool. That's why it's been like the primary project I've done for the past 10 years. I just do nothing but build compilers. A handful of games, mostly compilers though. Compilers are fun. I can't wait to get to VMs. I haven't built a VM, an interpreter, in so long. It's probably been like 5-6 years. So when we get there, I'm going to have a good time. We're going to have a fun time with the interpreter part. So now, the moment of truth, though, we've removed this. This is no longer hard-coded. We have the location information being printed, and if there's a string, we're printing the string. Now, we can go into the Lexer, and we can start getting tokens. We're going to do all the easy ones first. All of our single byte tokens are going to go here. So let's start with, I said less than. So I'm going to start with less than, and we're going to do complicated tokens later. We're going to put all of our single byte tokens in one spot. So we're going to say car, HBK token kind is going to be HBK token kind of the current character, right? Easy. And I think since we're in C23, I can do auto. That should work. I mean, clearly the VS Code doesn't like it, but I think I can do that, and that should just be fine. So then we can do Lexer Advanced to skip the token, and we don't even need to do auto kind actually, because we can just say token.kind. This. And the location information is the same. So then for all of the other single character tokens that we're going to want to use here, like, let's go through the keyboard here. I don't think we want a tilde. I think we do want a tilde. We'll use a tilde for the bitwise complement and probably XOR for shits and giggles. I don't know if we want a bang. I think we just want the keyword not. So no bang yet. We will want bang equals for not equals, probably. But probably no bang. At, I don't see a use for yet. For the length of something, maybe? We don't need a $sign. We do want a %. We do want a caret question mark, maybe? No caret for now. Ampersand for bitwise and. Then star for multiply, then open paren, close paren, minus, plus, go ahead and throw equal in there. Open bracket, close bracket, brace, brace, and we did need a pipe. I don't think we need a backslash for anything, so we've got less, greater. Before these we have comma and dot. We'll probably want all of those. This is going to be a semicolon language because it makes parsing less ambiguous, so we'll do a semicolon. We don't need a colon for anything explicitly right now. I'm just going to leave it at this. And some of these tokens are going to get pulled out, because less could also have less equal. Greater could also have greater equal. Equal could be equal equal, right? So we're probably also going to do things like plus equal, minus equal, whatever. But for now, this can show us, if we go into here, that some of these now are no longer invalid. They're at position 151, they have length 1. I didn't include a new line if it isn't invalid, so that's a problem. The new line should just always exist. F printf standard error. A new line. So now we have a bunch of our characters here, simple as function whatever, open parentheses for the arguments here. And since we're not storing the string literal anymore associated with it, there's no additional line here showing the actual text from the source file. We don't need it. It's just an open parentheses, right? Glad you randomly found this video in your recommendations. Starting college for CS, and I'm trying to learn ahead of time with C++. Hey, thanks. Glad you like this. We're going to keep this going. I've got another quote-unquote series on my channel where I was working on a more in-depth compiler, but I was very inconsistent about it because I didn't really like streaming it. I was just getting really in the zone, wanting to do some complicated things and not talk about it, so talking to chat was taking me way out of working on complicated things. But this I'm trying to keep simple. I'm doing it with the intent of being educational. So if you want to stick around, I've got a Discord channel where I talk about compilers and shit all the time. I've got a bunch of smart people in here who do other things. It's not just compilers. We talk about other things, but you can see that this is a lot of compiler talk. The link to it is in the description. My favorite person to talk to is Eternal here. Maybe don't bug him too much, but he's incredibly knowledgeable. He's been doing all this kind of shit. Like, he probably knows more C++ than the people on the standards committee. You know, there's always the joke that nobody knows everything about C++. He probably does. He's probably got the entire standard in his head. So if you're doing CS for C++, he is a great resource, so long as you don't make him annoyed. Don't bother him too much. Go join. I'll also be posting stream updates in the announcements channel here. Let me know if you want the notifications role, and I'll give you the notifications role. We love talking about programming, so I think you'll have a good time there. Okay, so that's the single byte stuff. How do we do multi-byte tokens? Let's do identifiers, because those are easy. We need a couple of things to help us with that. We're going to say static bool is identifier start. And we're going to call it HBK here, just because is identifier start. We want an int character. We're going to return true if C is greater than or equal to A and C is less than or equal to Z, or C is greater than or equal to capital A, and C is less than or equal to capital Z, or C is an underscore. And this is something I do all the time. It's very simple to me, but we know the ranges of ASCII values for these characters, and they are continuous. A is always the first lowercase letter, and Z is always the last. This is true for capital letters as well as numbers. Our identifiers in Hibiku can only start with these 3 character ranges. Read and that. The score range. Anyway, that's how we're going to determine the start of a character. I'll remove the comment for part, because you can very clearly see it 3 lines higher, but a part is going to be the same thing, but it's going to include numbers. So 0 is the lowest digit, 9 is the highest digit. The same as identifier start, but including digits. Identifiers cannot start with numbers, but they may contain them, right? So what we're going to do here, before we declare it invalid, we're going to say if is identifier start current character, I was going to say car, and then I said character, so character, current character. If it's an identifier, we're going to lex an identifier, which is as easy as while it's an identifier part, advance. And we can also token location length ++. Then before we break, we want to also store the string value of the token. And token kind will be token identifier. That's the one multi-byte that we have. Now we want to throw in here to do check for keywords, because keywords are first identifiers that you turn into keywords. Unless you do really fancy state machine stuff, you're never going to get to a keyword before you get to an identifier. So we're going to lex an identifier, and only if it is an identifier, we're going to check if it's a keyword as well. And we'll get to keywords, like I said, a little bit later. But with just this simple addition here, we should now have identifiers. So an identifier function. Now here's a problem. It includes the space. What I need to do is not plus plus every single time. I'm going to cheat real quick and just say minus minus. Because we already have a length 1. So here we go. Identifier starts at the very beginning of the file. It has 8 characters in it. Function. Easy. That'll be a keyword eventually, but there's our create adder initial value identifier here, right? We've now got actual lengths to our locations here, and they're all being returned as nice little stringy strings. So we still have some invalid stuff here with white space. We'll get into skipping white space. We're going to consider comments white space as well. That's a very easy way to just get rid of comments. So we're missing white space, including new lines. We're missing digits. We haven't parsed numbers yet. Numbers are pretty simple if we don't make them complicated. Well, we don't have strings. That's about it, though. Identifiers are very simple. You need to know how they start, and you need to know how they continue. An identifier in this language is going to start with any ASCII letter or an underscore, and it's going to continue with any ASCII letter or digit or underscore. So if it's not any of these, we're just going to check, hey, is the current character something that can start an identifier? Cool, it is. We're going to reset the length to 0 because we're counting here. So I think I'll be even more explicit and say equals 0. For as long as we are continuing an identifier, just increase the length by 1 and go to the next character. And it's that easy. So long as it can continue an identifier, you just do it. And we keep track of the length here. And now that we have the length from the location, we can just get the string value from our little view from location. A string view is just a pointer to the start of the string and the length, and C strings are just characters. So we have this many characters, that's our string view. And now it's an identifier. So let's get a C for add and commit with a message. We're going to say Lex identifiers. Cool. And push in a couple of commits. So up to date now, there's all of our commits for getting identifiers in place. And just out of curiosity, not this clock dot, we are at another 100-ish lines of code since the last time I checked. So cool. So we could do either numbers or keywords next. Numbers are going to be almost the exact same as identifiers, except if we start including floats, we'll check for the dot. But otherwise, it's just so long as it's a digit, do this, and we might parse a digit out of it, we might not. If we want to do keywords, that's going to be looking up keywords. I'll let you guys, if you answer in the next minute, do you want to do keywords or numbers? And we'll do whichever one you want to do. We'll probably do both today, but viewer engagement. Yes, I don't know. Keywords. Let's start with keywords. Let's go, viewer engagement. So let's do, we know one keyword right off the bat. We're going to do function. And you know what? Just to make it, we know we have a return in here as well. Return and function. If we look at our example, function and return, definitely going to be keywords. We'll probably have int be a keyword as well, and we'll probably have local be a keyword also. So you know what? That's our example file, return, local, and int. Those are the 4 keywords we're going to start with. Normally I don't prefix these, but you could prefix them with keyword to make sure they're easy to look up, but that's fine. They're already going to be included in here. They're already going to be printed because we're using our fancy X macro thing that you can read about on Wikipedia, wiki/X macro. Cool. In the Lexer, we want to do something here. We need to construct a lookup table for the string value of a keyword and the keyword kind in the token kind. So we're just going to make a struct. We're going to call it keyword info. There's a couple of different ways to do this. This is the easiest way I found to do it because we don't have hash maps in C by default, and I don't want to build one right now. So just doing a simple linear lookup on a small set of keywords is fine. So we're going to say token kind kind, and we're going to say const carve keyword like name image. I like to use the word image in a lot of cases for the, it's like a picture of the keyword, it's the name of the keyword, but it's like I don't know, I'm going to call it an image just because for some reason my brain thinks that's fine. What does the keyword look like? I think Clang, for example, calls this the spelling of things, which is arguably more accurate than image, but I just for some reason hate the word spelling, so I'm going to call it the image. And all we need to do is static keyword info keyword infos, and it's an array of size that we will determine at compile time. Since we're in C and we don't have lists either, I'm going to implicitly zero terminate this. So when it sees 0, it will know that's the end of the thing. So I don't have to do size calculations manually. I'm just going to iterate till I hit 0. And what this is just, we're going to have token function, and that will look like function. We'll have token return, which will look like return. We'll have token for int, which will look like int. We'll have a token for local, which will look like local. And I'm going to make this not so verbose in just a second, but I wanted to show you what we're doing first, and then we'll refactor it to an X macro as well. So there's all of our keyword information. All we have to do now that we have an identifier is, okay, we'll do for int I equals 0. Make it int64 just for some kind of consistency. Keyword infos sub I dot kind not equal to 0. So that's our exit condition. That's the end of the array. I++. We're going to add another condition just to make our lives easy. And token kind is equal to token identifier. So long as it is still an identifier and we haven't found a keyword, if stir and compare, which we don't have. Okay, so we're going to go include string.h. We're going to compare the keyword infos sub I dot text keyword image here. We should have just called it dot text. I guess that makes more sense. With the token string value data at token string value count. If this is equal to 0, which means they are equal, that's just the way that C works. That's the standard library. Token kind will then equal kind. And just to be a touch, I'm not going to say like consistent maybe, we don't really need a string value if we have a token. I'm going to just set it to 0. So HBK string view of 0. We don't need the string value anymore. We have the token kind to represent the keyword. And that should do it. If I come over here now and run knob on Hibiku again, this should say function. It doesn't have a string anymore because we know it's the function keyword. And it's that easy. You could do this with lookups. You could build a fancy state machine to tell character by character if it could or could not be a keyword. But the way I usually do it is there's only a handful of keywords in the language. Just iterate through an array and do a lookup manually. We have function, an identifier, and int. Hey, look, another keyword. And then eventually we have return. There's return, function. And then local should be down here. There it is. Cool. There's our keywords. So the one thing I wanted to do that's X macro style is we're currently... I might do this. I don't really have to do this. What I was going to say is either we provide a second X macro here, or we do token keyword kinds of X, and then include token keyword kinds of X here. And these become keywords of X. But then we'd have to have a Y happen. Rather, not X, but Y. But then this just probably gets a little too complicated to do it this way. when they hear the word state. Oh no. Because I don't want to like force everything to have comma there. So I probably won't actually do the X macro thing right now. I would do like, if you're not doing this kind of X macro, this is much easier. I'm trying to think of the way to do it without. This is probably fine. The way that I'm thinking of to make it easy is we just include a Y, and then all of these become Y, and so instead of being X macros, this is XY macro. But I have to define Y down here to be the exact same thing as X, and then I have to undef Y. And then I have to pass in X and Y, right? And then I have to do the exact same thing. Like, I don't think it's worth it right now. We might do an XY macro later. We might not. We're just going to do token kinds of X. The point was that eventually, maybe, I'd want to say function in line and then generate that table that we just did. But with this style of X macro, that's just not going to happen. I mean, it is. I could do it. I just don't want to do it right now. But that's it. That's how keywords work. The next thing we can do is else. We're going to do else if something. And we're going to move this into here so we don't have to break. Okay. So else if is digit. We'll just call it digit because that's what it is. The current character. If the current character is a digit, then we're going to start reading numbers. So we can just come over here and say is digit. And is digit just removes all of the letter parts. Blah, 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 blah. Boom. And I'm not going to handle like hexadecimal at the moment. We'll do that separately later, maybe. All I'm going to do now is parse an integer, and we'll worry about floats later. Because I want to parse the value, and parsing a float into a value is a little bit more difficult to do formally correctly. I could approximate it pretty easily, but it's probably not worth doing right now. So all we want to do here is, while it continues to be a digit, we go to the next character, but we're going to keep an accumulator of the value in token.integer value. So what we do there is we want int digit value, which is going to be the current character minus 0, not equals, minus 0. That's not minus, that's underscore. Minus equal 0. Fuck. Because we know 0 is the lowest digit, and we know it is a digit, if we do the ASCII value of this minus the ASCII value of 0, we'll get the digit value. Get the digit value. We know this character is an ASCII digit, so just get the difference between the two. 0 minus 0 is 0, 1 minus 0 is 1, etc. Right? Then we want to token dot integer value times equals 10, and token integer value plus equals digit value. Right? So basically shift all the digits to the left one. We're in base 10, so we do that times 10. And add the lowest digit. So now, just to see that in action, let's go in here and say else if token string value token kind is equal to, we'll need a new thing for HBK token integer literal, we call it. So we'll grab that, we'll make that a new thing in HBK lex h. We'll say x of this, put it there even. If it's an integer literal, then fprintf standard error space mod lb look in int like that. Why is it not happy? There is clearly a string value. It's right there. You navigated to string value. What the hell? What the hell? What the hell? Does it build? It does. At least, I mean, I didn't see an error, no. Okay, well, VS Code bonked. The next thing we want to do in here is we want there to be no string value. Not being set anywhere, so that's fine. But then token kind equals integer literal. I don't think we have a 7. Integer literal 7. Not in quotes, not in this thing. It is an integer literal, its value is 7. So let's go into our example file and just say local v equals 102 dabba dabba. You know what? My favorite though is 24601. 24,600. This will be easier for us to see. Local space, we need to skip spaces. Identifier v equals the integer literal 2461, 24601 with a semicolon. So now, other than spaces, we've done everything in this line. So let's just go handle some spaces. We handle spaces we could handle them in a couple of locations. Normally I handle them inside read token, but I think I'm just going to handle them here. We're going to start by hbk lexer, skip white space, lexer here. And then after reading a token, we're going to skip white space again. And it's that easy. So right above read token, static void, hbk lexer l. Anything that we could consider white space, we just skip over. That's what we're going to do. Oh god, hiccups. That's what we're going to do. So while something, I'm just going to say while true, and we're going to break out of it if it's not true. So let's grab is space function first. Is space c, we're going to say c is equal to the actual space, or c is equal to the tab, or c is equal to carriage return, or c is equal to the new line character, or c is equal to a vertical space, whatever the hell that is, and that's all I care about right now. True does not exist, so fuck it. 4. No, that's bad. While. I'm gonna just make VS Code happy and turn these into true, and this one's true. This one's false. Oh, you know what? It might not even like that. No, it does. We're fine. No, it doesn't. Because it's defined C23, and but this is not even, it's not even C plus, but define false false. Well, that's weird. UTF-8 support will happen soonish. We only have to implement UTF-8 characters in here, these two functions. Everything else is basically dependent on this. So whenever we want to do UTF-8, we just put it here and it'll work. We're already returning a character as an integer, so we don't have to change any of the types anywhere. And nothing that we're caring about right now even cares about Unicode, so it doesn't break. All I then have to do for identifier start here, I guess we could go ahead and do that. Or C is greater than 256, and we just accept all multi-byte characters as identifier characters. Optionally, we also said any non-ASCII character is a non-identifier character. See, cool. Now, whenever we actually lex and construct, Unicode code points. It'll be fine. This stupid bullshit. Why it no work? Can I define fucking true and false? Probably not without a value. Why not? Why not? That doesn't help at all. EDG parser. One of the C++ workaround here. Add true equals 1 and false equals 0. That's what I was about to do. True equals 1. False equals 0. And bool equals fucking no. Don't have to because it works for some reason. There we go. 1. Okay, love workarounds. Let's go. So now we're back to white space. To do white space, we're going to forever loop and just break out of it. So we need if is space observe current character L, then advance L. I'm going to say else break. Now the reason we're doing this and not putting this in the condition is because we're also going to skip comments here when we get to comments. But for right now, so long as there is a space, advance, otherwise break. So now, if we run this, we don't have spaces. At least we shouldn't. We have this 0. So, interesting, that shouldn't be there. That's the null terminating character. It's a 0 length string. I haven't drink water in like 4 hours. Alrighty. So, why are we hitting 0? By the time we hit 0, it's a null terminated string. I want to eventually support 0 in things, technically. Like, it's a bad idea, but I want to do it anyway. So, why? You just skip 0. 0's fine to skip. If I skip 0, does that remove it? That infinite loops. That's what I was afraid of. Yep. That's why I want to technically support it. While not is EOF, it's still going to give us 0 at the end. But I could C is equal to 0, and that would stop it, right? But I don't want to have to do that. That's a hack. That's a hackety. So when we say advance, position plus plus, then EOF is position is greater than or equal to text count. So what that begs the question is, what is text count minus 1? Let me go into knob and make file. We want to C flags include ggdb in there and in here. ggdb knob and Hibiku. Okay, so it's still running, it's rebuilt. Don't need makefile tools. We're going to go to lex.c wherever we get the text here. And we're going to just put a breakpoint anywhere else. If I run, we then need default configuration. Open the launch.json. It didn't give me a configuration. So what the hell do I need? Missing property name. Debug. Then we want, what's next? We need the property type. CPP debug, sure. The request. What is request? Launch. That's what request is. Then we want program. Program. Workspace Hibiku. We don't have any arguments yet, so I'm just going to debug. Launch current working directory is missing or empty. Oh. Okay. Didn't want it, but CWD. Workspace root. Launch. Cool. So text data. Problem, I guess it's not technically a C string, is it? I mean, it is. We're seeing it. It's going to be null terminated. So the count of this is 17. I go into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. The column says 17, so 17 minus 1, 16. So it's including a null terminator in the length. That's all I wanted to see. So in hibiku.c, this one, the count, because the count is +1 for the array, but we don't want the count to include this. The string should always be null terminated, but it shouldn't explicitly have a length including the null termination. So set count should probably be called here to generate stuff. Then I should do set count to file length, I guess, to be explicit about what's going on. There it is. It's not invalid. We've fixed the problem. I should just say ensure capacity and then set length, but I don't want to have to call HBK ensure capacity manually with like source text size of source text and minimum capacity of file length. I could do that there, and then I can set the explicit length here. Right, that would still work, maybe. I have to see, then I have to manually cast it to void star. So what we probably want to do is what? Do I have a set capacity? HBK vector set capacity. Then I can say regular ass source text. File length +1. Set the count to 1 less than that. So then let's go to count, and we want to set count. This just needs to be vector ensure capacity without setting the count at all. So then this is capacity. Right? So then that should do the same thing. There we go. Boom, 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 boom. I want you in my room. Spend that night together. Okay, so now. We have integer literals. Yes, we added integer literals, question mark. We did. Get a C, add integer literals. I'm going to push those changes. Cool. So now we've lexed most of what I want. We did integer literals plus fucking comments and spaces. We haven't done comments yet. So that's technically incorrect, but it's fine. Let's go lex some comments. And then we can do multi-byte characters. Multi-byte non-identifier, whatever the fuck characters. So we need a new function. We need else if something, and that something is HBK Lexer peak car L is equal to S this, as well as we just need to know if current car is equal to slash and we peak a car. So let's go to current car. So now we have three functions that need to have Unicode support. Return the next character. Return the character after the current position of this Lexer. The next character if not at the end of the file, otherwise 0. And then we want to say int64t peak position is going to be L position plus 1. And then we're just going to replace L position everywhere here with peak position. Return 0, otherwise the next one. So then this is called peak bar. If we see double slash, we're going to while not HBK Lexer is ELFL. HBK, that's why I wasn't talking about deleting. HBK is ELF. And current car not equal to the new line character. We just advance. Skip everything that's not a new line character, and that's a line comment. So we can, that's not what I wanted to do. I wanted to not Hikaru. There's local identifier equals integer literal, whatever. Let's go add a comment. That says this is a comment. It's effectively white space. And look at that. It is effectively white space. It does not show up in the output. Git AC, add line comments, push. The limited comments, like block comments, are technically slightly harder to do, especially so if you want to nest them. But we can go ahead and do it anyway. It'll just take a second longer. So we're going to say, look, int nesting is going to start in 1. And this happens if we hit /star. Our nesting is 1, and I'm going to advance past both of them to ensure we don't have any issues. So then what we want to do is, while we're not at the end of file, and then we're going to have an error to report. If nesting is greater than 0, to do local report an error. But what we want to do here is keep track of the current nesting level as well as the characters. So we're going to say int last character is 0. Then we're going to say somewhere in here that last character equals current car of L. Right? Then the current character should really be this. So int current character. Then last character becomes current character. So if last character is equal to star and current character is equal to flat. So nesting is greater than 0. While there is something to close and we're not at the end of the file, then we can say nesting minus minus, and we'll want to advance regardless. But if it's the end of a block, we reduce the nesting of blocks. Then if the nesting is greater than 0, we report an error. Otherwise, we have successfully closed all of our blocks. So I believe this will give us nested block comments. Let's go to, closed it already. Hello, Hibiku. This is a block comment, which allows you to include new lines in your oh. See, so this didn't work. New lines in your comments. I forgot to increase the nesting. That's the next thing to do. Else if last car is equal to slash and current car is equal to star, then nesting plus plus, and in both cases, we're going to set current car equal to 0, so that it doesn't count the thing accidentally twice. So now we no longer have block comments. This was a little complicated, so do ask me if you want this explained. I just don't know how better to explain it in comments. Like, I was going to comment this. Let's try to explain it in comments. The number of currently open block comments. We support nesting block comments, so we need to keep track of how many are currently open. We know how many we close. Since the open close delimiters. Hi, Ruben. Oh, that's good. I have no idea what happened to Lens, and I'm not necessarily gonna discuss it. If you want to talk about it, I can't stop you from going to off topic and asking, because I am curious, but I'm not gonna like speculate about what the hell's going on with him. I'm not gonna gossip about him. I don't know. He kind of got angry, and I left after that happened because he nuked his server. And I was like, cool. There's nothing to talk about. The server's empty. I don't know. So I don't hear from him. I haven't DM'd him. He hasn't DM'd me. I kind of want to DM him, but also I don't want to get fucking yelled at, so I don't know. Since the open close delimiters are 2 characters, we simply track the last character we saw. And then if we hit new open and close for the block comment, if the last character was star and the current is slash, closing 1. Opposite is true if the last character was. Yeah, have a good day, Joy. I'm glad you appreciate it. I'll try to keep doing it. If I slow down, go pester me maybe, because I want to finish this. I want to try writing something. So pester me in my Discord maybe. But yeah, no, have a good day. Thanks for stopping by. If the last character was slash and the current character is star, we're opening a new one. In both cases, to prevent things like both opening and closing at the same time. Overlapping delimiters, we set the current tracked character to 0. Cool. If we hit the end of the file and there are still nestings, then we didn't properly close some of the block comments. Report an error letting the user know that something went wrong somewhere. So in order to get this, we will want to get the locations. Let's say HBK location, start location, which we can actually just do in here, the only place we care about it, equals location create from L source ID, L position 1, and we'll make it actually 2, because we know it's 2. So then we can use this start location to report that there's an unclosed somewhere. We can maybe eventually keep track of every single opening one, and then work our way back from there to determine which nesting is not closed. To do track multiple locations from each open, so we can report unclosed block comments more accurately if there are multiple. But for right now, that is an implementation of block comments. We've got line comments, block comments, and white space all being skipped. We're not storing them anywhere. So one of the last things we have to do in this lecture is turn some of these into multiples. So we're going to do that, starting with equals, because equals is easy. And we're going to generalize equals into a lot of other things. So we're going to always advance first. Then if current car of L is equal to equal, then we advance again. And we say that the token kind equals HBK token equal. Else the token kind just becomes the regular equal. So what we need to do here is go back into our Lexer header file and add a fuck ton of operators. So we need like equal. And what I'm going to do here actually is just copy a bunch from laye include laye.h. And so way the hell down here, I have a bunch of operators already. So we'll start here and we'll remove the ones we don't need. I just don't want to have to type a fuck ton of things. So less for left shift, greater for right shift, equal for equality, bang equal for inequality, plus equal for assign equal, minus equal, slash equal, star equal, percent equal, less equal for comparison, greater equal for comparison, ampersand equal for the three bitwise are here, left shift equal, right shift equal greater, I think we're going to keep. Less minus is a new slot operator that I don't think we need. We don't need colon. We might do colon later, but we don't need it right now. So these are all we're going to support. Maybe we do plus and minus. I'm eventually going to support that in laye, but I just never added it. So, you know, do I still have it open? I think I closed it. Let me open it back up. I'm just going to fucking add it right here. Cool. Okay, so those are the handful of things that we're going to support. Let's move this off to the side. And, oh, it's not equal. It's like this. Cool. So we have equal. Equal is easy. Equal could also be equal greater. I believe we kept that. Equal greater. So in order to do it again, we want, if it's equal to the greater, then it's equal greater. Like that. So then we can do bang not equal, which I don't think has anything other than bang equal. So we can remove 1, 2, 3, like that. This, though, for plus, let's remove, we didn't have a bang up there, but we do have a plus. Plus is going to get removed from here. It's plus here, then it's plus equal. If it's plus, then it's plus. Otherwise, it's just plus. If it is minus, then this is minus. Minus plus, minus equal. Minus equal, minus. Okay, so now we can remove minus from up here. Then we can do star, slash, and modulo. Star, I don't actually have slash in here. Percent and slash is going to get added. Star becomes I think I need to call it star. Slash and percent. Percent equal. Okay, so then we have a couple cases for less and greater. Steel less and greater. Less greater. So less could be less equal. It could be less, less, and it could also be less, less equal. So we can grab basically the contents of this and just put it in here. If it's less, then this is less equal. Else it's less. Right? Less equal. And then we do the exact same thing for greater. Like that. And then. Let's see. Pipe, ampersand, and tilde. I think the only ones left. So those are going to be very simple, similar to star. So pipe, be pipe. Ampersand to be ampersand and tilde equal. Right. Then there. Not what I wanted to do. We're going to have this. Okay, doesn't break. That's good. And then I do think I want to go do a separate X macro thing to get us these keywords, because we're about to add a bunch of keywords. So we have HBK token kinds. We have X, and we're also going to have a W. Let's just say TK instead of X. For all of the above TK. And then for some of them, they're going to become keywords. And that's all these ones at the bottom. So we can define TK, pass in TK and KW. KW, and do the same thing, undef KW and def. Then we have to do that at the top of Lex as well. Keyword and TK are the same thing. Keyword A, TK, KW. But then what I want to do here is define TK to do nothing, and define keyword to do something. What I should do is copy this into each of these. Keyword needs something. So this needs to be int. If my fingers could hit the shift key in the correct location, local, return, function, format, then this one doesn't need ... It needs image. So then we can just say HBK token n this undef KW, undef TK, and oops, go back to token kinds, TKKW format. This is just not in the correct spot, but that might be something I have to live with. Anyway, now should still work, cool, but we've X macroed it, so we can add as many keywords as we want, and nothing bad can happen. So back in Lex, we want a couple more keywords for fun. We want and, we want or, we want not. Those are going to be key and, or, not. We want, I lost function mix. Function. We want return, break. We want continue. That. We want if, while, for. So if, while, for. If, else, else. Now we've got a bunch of keywords. For other data types, we'll probably want int string should probably be built in. Probably also bool and float. Bool and float. Then, if we get around to things like structured types, we'll want a struct keyword or a type or something. And we have comma, we have return, break, continue, if, for, else, while. Function is going to both be a type and value specifier. Local is, local is here. We're gonna put local over here. Function. We could do exporting and importing of things, but I think everything should just be public for now. We do want some kind of import keyword. Then hopefully not much else. I don't want to overcomplicate things here. Int, float, bool, string. If we have a string, we probably want a character, but a character could just be an integer. That's fine. So if we have a bool, actually, that means we want to else to get bool, which also means we want, I'll put these up here with and or not. True, false, we want a nil or a null, nil. Then. What else to do? 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 Let's see, enum is probably a good one to have, honestly. And when we get to structured types, const maybe. We have local to define local. Like global variables wouldn't do that. Const might be useful for compile time constants. And they'd have to be source only probably. So let's say const. Probably don't need anything else other than that, right? Okay. I think, other than reporting errors, that's all I need to do right now. Lexer. Oh, strings. We need strings. We can do really simple strings. Token kinds here. Case label already has one of them. Not bool. This is false. This is true. That should fix that problem. Okay. So we need to do strings. So to append to a string, we already have a vector push. So that's fine. Let's do problem. We're not, okay, so we're not going to do escape sequences. No, we can do escape sequences. That's fine. That's fine. Yeah. Okay. Let's do strings. Case string. And we're also going to say this, and we can say bool is car lit is current car L is equal to this. That'll be how we limit which character or which how many characters you can put. So let's just say car delim is this. Then. All we have to do is similar to this. While we're not at the end of file, and current is not equal to the lim, do a thing. We're going to say the location length is advance L. That's fine. Location length doesn't need to be reset. Then if current car L not equal to the lim, we do report an unfinished string literal. Then we also need to report bool is car too long. False is car. Let's just say int n cars. It's 0. N cars plus plus. If is car lit and n cars not equal to 0. We do local report that our character literal requires exactly one character. Otherwise, we then want to keep track of our string. So what we should actually do here, say car c equals this, vector push token dot string value c, right? And if it's an escape sequence, we'll do something different. So then this is car c. Oh, because it's a string view. Oh, we have to go allocate our own string. So we can lex a string literal, but we can't yet get the value of a string literal. So let's say print hello world. Then the lexer will read hello world just fine. It just won't print me anything. So what I can do for now is just steal the string value calculation here and say this. Oops, just a second. Okay, have returned. Too small. We'll go there. Where's my chat? Okay. So token location dot length plus plus again. And then we get the string value and we say token kind equals HBK token string literal. Right. Then go to here. Go to, we have an integer literal somewhere. There it is. String literal. Cool. So that should get us string literal of hello world. It doesn't have the value yet. We've got to, this is where we want to start interning strings probably and get an owned copy of a string. So I'm just going to say do local generate and intern the string literal value, please. But we'll go ahead and add get cm select string literals without storing the value. Oh, I didn't want cm, I wanted ac. Push. And there we go. So we're at the point where we've lexed just about everything that we could ever want, save for the value here. So what we can do, though, the easiest thing I can do here is say if ncars is equal to 0 and is carlet, then we can say, what the hell am I thinking of? Token integer value is C. So I can come over to Alexer into Hibiku and say, else if it's character literal, it would just be an integer literal, really. It would be an integer literal. But it would be a character literal. It would be. The type of a character literal would become an integer value. It would become an integer, but the token is still a character literal. So we're going to say is carlet and character literal, else string literal. That will go here. So then if it's character literal, we're going to print mod C instead of mod. So then we can come over here and just say, hey, 1, that should lex, 2, it should give me the correct thing. Character literal of A. Beautiful. But it's not actually giving me that value. So in lex is carlet is true, and cars, did it just not? Oh, because this needs to be the last case. If this there's a. Cool. So we've got character literal. We don't have a string literal yet. I might make that the last thing I do before I get off. As soon as this lecture is done or close enough to done, I'm calling it for the day. It'll have been 4.5 to 5 hours of streaming, I think. We're at 4.5. So we'll probably end just over 4.5. So the interning thing that I want is in probably API, HBK API. I think we want to HBK string view. We'll put it under this one. HBK state intern string. So we'll want to intern a string from a vector, probably. So I think what we want to do, since it's a vector, we can just use HBK string. HBK state, state, HBK string, string. This will, at brief, interns the data of the given string. Intern a string, the state creates a copy of it that it owns and returns to you a view. This way, all instances of that string and point to the same memory. An interned string is immutable. So we can have an intern string and an intern C string. Pointer string. The string value is freed. Question mark? No, it doesn't need to do that. We're not going to free the string. We can free the string ourselves. So now we can grab both of these into HBK API. And actually, this needs to not be an HBK API. It needs to be in Hibiku, doesn't it? Like an implement in Hibiku. That's right. Hibiku. String view. We should be able to then include HBK string, HBK string, H. Right? That just exists. Oh, we're in the wrong Hibiku. That's why. The two hibiku.c files. API should already have string, so I should be able to come over here to this one, say this. Cool. So then, what is wrong here? Nothing is wrong here, it's just mad. So then we can say HBK string string data is null. Let's say if is carlet first, then if it's the first character, store the value. Else it's not a character literal. So then we can do vector push string data C car C, like that, right? Vector push car C. If is car lit, if n car is not equal to whatever, else could be empty, so we're going to not check that. Then we're going to say token string value equals string intern string. And that's going to be string data. And then I can vector, say HBK vector free of string data. So we're going to go implement vector free in the vector. So we have vector count, we'll put define vector free first. That'll be a do while 0 kind of situation here. And all that's going to do is two things. We're going to say free v get header, free get vector header of v. We're going to do that only if v, free get vector header of v, and then we can say v is null. And that should vector free. So, boom. So we want to intern from state string data. That gives us our string value. And we L state string data, free the thing. So then here we don't need this. And we'll move this after because it just feels right. Okay, so then we have to go implement intern string. For now, the way we're going to intern strings is naive at best, but we're going to say vector of HBK string interned strings, and then we need a memory block to put them in. And this needs to be HBK string view interned strings. And the thing we're going to put them in will eventually be to do local create an intern, create a tool for string intern. For right now, I'm just going to reallocate them and return a view, and eventually we're going to want to put them in a pool. So what we're going to do here is const car data equals malloc. I'm going to say calloc string dot. Actually, I'm going to flip this. It's going to be one of string dot count. It's a vector count string, right? And that's not a size t, but it's probably convertible to a size t. Size t there. Plus one. Mem copy into data string and return HBK string view. So let me just grab this and say int64t length is this length dot count is length and dot data equals data. Cool. So then we're going to do the same thing here to take mem copy length is then sterlen string, and that's just an int64t of sterlen. Same thing. So then to do for both of these, to do local actually lookups when we get there. So then even better, we don't need this just yet because we don't have the thing to pool from. Well, actually, we should do a lookup. Let's go ahead and do the lookup. Actually, intern in the pool, we're going to do a pool, but what we're going to do first is for int 64t I equals 0, I is less than vector count of state interned strings, I is plus. So then we want to if stir and compare. All of our intern strings should be null terminated, so we're going to say state intern strings sub I dot data versus string data string of length. If that is equal to 0, then we can just return this. And we can make ourselves slightly easier if this dot count does not equal to length. Thank you. Return it if it exists. So then do a similar thing here. If stir and comp of string plus the length, actually the same thing. Continue. Cool. So now we should have interned strings that actually work. We go back in Lex, we're interning the string, we're freeing the data. String value should exist. So let's go back into our Hibiku and say print hello world. And then in hibiku.c, when we're printing it, I'm going to add another case for string value, which is going to be almost identical here, except I'm going to do actual quotes. Here. So data const char cannot be, yep, hold on. We're not allocating constant memory. And need to define free in vector, which comes from standard lib. There we go. String literal hello world. It's got all the correct information in it. It doesn't have extra stuff. Identifier print hello world. Beautiful. Git AC at string literal storage. Push. Cool. So we have a couple of things left to do. We should probably go ahead and make a to-do.md. We can say to-do. One of the things to do is going to be string interning in that pool within HBK state, which implies create a pool allocator, a pool allocator, string interning in the pool with HBK state. Eventually, we need lex float literals. Eventually, we need lex decimal literals. We might do other bases. I don't know yet. I think of, let's just go look in here and find to do. Yep, to do. We need diagnostics. Do actually, yeah, we just don't need anything in nom.h. Oh yeah, to do for me. So we've done not as important. Diagnostics, interns. Actually, this is done. We've done this. So that's good. Unfinished string literals. So let's do a sub for diagnostics. Unfinished string literal, non-zero length character literal, then unexpected, unrecognized character in source. Report an error for what? Unclosed block comments. And I think that's it. Then we can git AC and to-do file, push. And with that, we're going to get back to this at a later date. Thank you guys for stopping by. Don't forget, you can join the Discord. I've said it like, I don't know, 100 times this stream, but join the Discord. You'll see when I get to go live. Get to talk to a bunch of smart people about compilers and other programs and stuff. We are programmers. You could also talk about philosophy. Nobody does that, but you could. Post some shit posts. I killed myself in a Hunger Games simulator. Linguistics every now and then. A few months ago was working on a language. Haven't brought it back up, but maybe I will. Hopefully I will. Look at how pretty it is. I made that font. It's great. Go do whatever the hell you want. Join the Discord. Talk to people. Nothing better than learning from other people. I am going to go get lunch and maybe do some cleanup. Keep an eye on the Git repository if you want to see it. Build instructions are in there. We're going to be writing some blog posts about this. I might do that on stream. I might do that off stream. I don't know. But if you want to see me write those blog posts, you can find my website when I do in the Discord as well. Give me some feedback. I'll probably be asking for it. Lots of things, all the engagements. Subscribe, I guess, if you haven't. I'm going to keep doing this. And thanks for watching. I'm going. Goodbye.